Hello everyone, to the first session of GitLab. Today we will walk you through the basic setup of GitLab, creating some group projects, repositories, cloning them, and then creating a sample Java project and pushing it to the GitLab. So we will be using the GitLab as our version control, as it is the most widely used version control nowadays for maintaining the codes, and used by various developers and also many industries. So let's quickly get started. So the first, we would create the new group for our repository. So every repository should belong to some group because it has some unique identity according to the groups. So let's go to the go to your favorite browser and we will hit gitlab.com. So once we go gitlab.com, it will ask you for sign in and sign up. So if you don't have existing account, you can create the new one, and if you have, you can just log in. So once you log in, you will have an option to create project, create group, and two more options. But okay, so for now we will go and create a group. So we'll say create group. So you will see some port page like this. It will ask you for the group name. So I will choose as Maya_Java. I will provide some description, and then I will keep this group as private, and I will say create group. So our group created, so it would look somewhat like this way. Then we will now let's navigate to the second step, that is to create the project, or we can say more probably to create the repository. So we will say new project, and then we will choose our, so we see here we have four options. So rest of the three we would cover later, but for this tutorial we will say create blank project, and it will ask us for the project name. We will say Spring Security. For now I will choose it as for my project name. You can choose whatever you want. Then you can provide some description. Okay, and I will also keep it as private, and then I say create project. So now we have created our project. So you can see now we have a repository, but it's empty. We do not have anything yet in this repository. Now next step is to clone our repository. So to clone our repository, we will be using a tool called Git Bash. So you should have Git Bash installed on your system, and if you do not know, then you can just go to the Git. You can just search Git download, and you will see download Git website. This is githcm.com. It will be available in the description, and you can see you can download it from here, any version you want for your system, that is Windows, Linux, or Mac OS. So once you get install your Git on your system, and you will hit Git Bash, you search for the Git Bash tool, and it would be somewhat like this way. So you will have, once you have Git on your system, you will see a bash where we can actually use git commands to clone our repository or various commands. So now once we have installed, we will be cloning our repository using HTTPS. So there are two ways, like clone with SSH, clone with HTTPS. So for SSH we will take up in next session. For HTTPS we will take it for now. So I will just copy this HTTPS URL. I will navigate to my git bash, and I will say git clone and my URL, and I will say hit. So it says destination path Spring Security already exists. So maybe I have already cloned it once. Let me just clear it out. Yep. So I will just clear it once. Okay, now we will clone it again. So it says cloning into Spring Security. Okay, so now it says you have cloned an empty repository. As we can see, we do not have any files or something is still on our repository, so it says empty repository. So we'll just check it. So we have Spring Security on our local system, so we will just navigate to our Spring Security folder, and now you see defaultly Git always has the cursor over the master branch. So this is one of the branch, the master branch, where we will be putting our first file. So we have cloned our repository. Now we will create our master branch in the git remote directory. So if you navigate to the browser, you see we do not have yet any branch or any repository files over here. So we will just create one file which is readme.md file. So I will say this is my first Git tutorial. Okay, then I will create one readme.md file. Okay, now if we check, so we have readme.md file ready with us. Now I will check the status. So git status is a command which actually tells you that what all files are in the stage area or to be committed, or which are not part of a commit or something. So when we say git status, it shows me readme md file dot in red color, and it comes under the untracked file. So it says that git does not have a track of this file right now. So I will use git add dot. So this is the command which actually put all the new files into the stage area. So that is, now git tracks them. So I will say git add dot. Now if you again do git status, now you see the file in the green color. Now git understands that, okay, this is the new file that has to be go to the remote repository. Then I will say git config user.email. Now this I am doing right now is to set my authentication username. Like Git works on authentication, that okay, a particular user of the repository should only be allowed to push or pull from files or anything from the repository. So I'm configuring my user that this will be the user who is gonna work on the repository. So once you configure it, then I will say git commit, then -m. So -m means the message which will be your part of your commit. So I will say my first commit. Okay, so now you see I have created one file. So it says committed state, then I will say git push. Now it's a now let's wait. We would take few minutes. Okay, now you see that we have created a new master branch and we have pushed our file. Now let's go and refresh our browser, and we will see our readme file is present here. Now this is our commit, and this is our readme file, and we have it on master branch. So we created the master branch. Now next we will create some sample Java project and we will push it inside the GitLab. So for that, in this tutorial I will be using IntelliJ for our project creation. You can use any IDE, whatever you want, Eclipse or Atom or anyone. So I will say create a project, then it will ask me like a lot of texts are here, like Java, Spring, Cloud, and Kotlin, Maven. So I will use a Spring initializer for now. So this is something start.spring.io available, so you can get it from description. So I will say next, then it will ask me for my group name, then I will say com.maya.java, and my project name would be Spring Security. Okay, then lots of other options. This we will discuss later when we will have some other Java tutorials. So this config is done. Okay, so it says illegal character. Okay, so artifact should not have a space in it, so it should be something like that. Okay, so now it asks for dependencies. So dependencies is one of the dependent modules which Java project needs, like libraries and all. So for now I will just take a few from this one from this one, and as you see, this is the Spring Security tutorial, so you can see I will just use this Spring Security for sure. Okay, then next, then I will set my project location would be this, and then I say finish. Okay, let's wait a couple of seconds. It will take time to prepare a project repository. So it's preparing a project. Okay, so now you see our project is ready in our repository. So I will quickly navigate to the git bash, and I will just check git status. And now you see the files which we have created are in red as they are untracked file. So we will move it to GitLab. So likewise, we will say the project creation is completed. Now we will push this project to the remote repository. So we'll say git add dot and git commit -m, and then we will say my first project, enter. Okay, so it's all being created. Now we will just push the push. Okay, now we have this project file pushed to the master. Now we will navigate to the browser. We will refresh this git. Okay, now you see that we have a project in the repository with all the Java project we created. For now it's in the master branch, and we have this is in our repository. So we have pushed new Java project. I think for this tutorial, that is all was the basic understanding of how to create a group, the project, repository cloning, then master branch, and sample Java project, and then pushing it to GitLab. That is all for this tutorial. Now we will meet in the next session.
Today we are back with one more session on GitLab where we will focus more about the features of GitLab. Hope everyone has gone through my earlier video. If not, you can find the link in my description of this video, and you can refer my old GitLab video where you can understand the basics of GitLab. So not waiting too much, let's get started. Oh, but before we start, I would like you to all that please subscribe my channel for the upcoming videos, latest videos that would be coming. So would like you all to subscribe, please like, please share, and expand it as much. Your help is a lot needed. So just need to go to the YouTube, and you have to just click on this red button you see here. So please subscribe, guys. Okay, so let's begin with our agenda today. Today we will walk you through the features present in GitLab and their use. So today, I will log into the GitLab repository, and I will walk you through each of the sets of options that are available, how you can use them, in which scenario you can use them, and then in the later upcoming videos we will learn how to use those features and exactly going to implement them on any real-time system, or while developing any product or whatever. So that would be our agenda. So let's navigate to our own gitlab.com, where I have created our group my_java with my repository as a Spring security in my earlier video. So I will just quickly click on it. And now, so let's start with the options that are present on the left panel. So we see the project overview. So project overview is some option where you can just check all about the project. That okay, you can say like a summary of your projects. Okay, how much storage does your project takes, or how much size of your files, branch, and how many commits did you make, a lot of other things you can see it like in a summary point of view. Then we have the next option as an activity. So activity is a tab where you can actually find out all the activities that have happened against your repository. So like how many push have been done on your repository, how many merge have been done, how many issues or any comments, design, and how many team members do you have. So these kind of activities you observe on this activity tab. Moving to the release one. So releases tab is something when whenever you develop a product, you have lots of stages, like staging area where you try to develop a product, test it, you test it, and then you pre-launch it, and then you go for production, launching in the market. So these are some stages which are also known as releases. So this is where you can check releases on the environments. Then moving to our repository. So in repository, the first comes the files. So files is something where you can see your repository, that okay, how many files do you have in your project repository, and you see the option of the branch as well, that how many branches do you have. So you can select the branches if you have multiple branches you are working on. And also you can check your history, you can find any file if you want. You can use any web IDE, in the sense, instead if you do not have any Eclipse, IntelliJ IDE to edit your project, then you can use a GitLab inbuilt web IDE for your development. Or you have also an option to download this source code in the form of zip onto your system. And this feature I have already covered, that is clone your clone repository to your local. Then let's move to the next section. So next section is the commit section. So commits is something where you see all the commits that have been made in your repository. So this is something where you make it so you can select, if you have multiple branches, you can select the branch and you can check the commit you have on your system. And you can see the author, that okay, how many authors do you have on those commits. So a lot of events of commit you can see in the section of commits. Then we will move to the branches section. So as you can see that we have only one branch in this repository. So the default, when you ever create this GitLab repository, it always comes with a master branch. So we call it as default and we call it as protected. So protected means that you cannot delete this branch. You can have multiple branches based on your structure, how you want to structure it. Most probably we will cover the branching strategy also, and that is where a lot of branches comes into picture. Let's move to the tags section. So tags is something where you tag a particular release or a version, like okay, your initial product release, your initial launch. So you tag those releases. So in near future, if you want to find it out, okay, which release was that, you can just get it through your tags, and like that way. Then the next option you have is the contributor. So contributor is a feature given by repository of the GitLab, that you can check how who people, how many users, or how many contributors are there on your GitLab. So if you are launching a product, you can just check your contributors in the GitLab. So for currently I don't have any users, so that's why I see only one user, that is my award. But yeah, probably if you have lots of users in the repository, then definitely you will see lots of users contribution. Okay, what time, what duration, what all things they have contributed. So you can specifically identify that who had made the best contribution to your project. Then we have the graph. So graph is something which shows your all the commits, and all the revisions which you had been committed to your any branches you have, like master. So here I have master, so it says okay, the first was my first commit, then my first project, then I deleted these files. So this is all graphical way of representation. The next option we have is the compare option. So like if you have multiple branches, and like branch 1 has some code and branch 2 has some code, now you are confused, okay, what branch has the latest code, or maybe you can check okay, which branch has my code. So you can actually compare those branches and find out the difference between them. And this also helps you to solve the problem. For example, any developer is working, they have created some new stuff, and the other developer also created new stuff, so this option comes in. So you can compare, and both both developers stuff can be merged into a single stuff. So that is where compare comes into picture. Then we have this issues board. So issues is we can say issues is like while developing any application or something, you have lots of issues coming into your application. It could be a bug, it could be any problem, or it could be any logical solution where it is not working correct. So these lots of issues should be tracked in this section. So you have boards for it, you have labels against those, you have service desk, and milestone. So you can decide the milestones for those, like okay, what time it would be the time for that particular issue to be solved, it should be covered in what milestone. And various tools are coming to track these kind of things, which probably I would say Wiki, Jira, These are some tools where keep your issues, so you can link it with your GitLab to have those issues tracking. Then we will say merge request. So merge request is a place where lots of requests comes in from different in developers who are developing the product. They develop a certain piece of code, they test it on their end, then they push it to their local branch. Now once they have it on their local branch and they push it to the remote branch, then what they do, this piece of code has to be a part of your master branch or production branch. So there is a merge request, and the approval of the merge request reviews their code or whatever they want. They approve it on some various level, like okay, code standards, or verify those few things, and then they pass the merge request, and it gets merged into your master branch or your production branch. When we talk about the CI/CD, so this is one of the best feature which GitLab provide, because here we have the continuous integration and continuous deployment of your project. So this is one of the best you can say feature, where you just write a piece of code, you push it into your repository, and it get deployed on your product test server, or maybe you can say dev server. So immediately you write a code, you push it, you get it deployed on a test server, and you can test it as per your functional or whatever has been provided to be developed. Now this feature is accomplished by pipelines. So pipeline is a line which has some stages. So you can say like build stage, test stage, or you can say automate test stage, or you can say artifact upload, and then you deploy it on our different servers, dev server, test server, or production server. So pipeline works that way. Now we can run these pipelines also using the jobs feature. So jobs is something you write it that okay, uh, when this event happens or this has happened, then pipeline should run. So this is where your jobs comes into your picture. To schedule these jobs, you have a schedule ready, so you can say like okay, on Sunday night 12 p.m. The job should run and it should invoke the pipeline. So this is how all the three parts are interrelated with each other. Then we say security and compliance. So as you know, every product should be very much compliant to their security. You should know about their vulnerabilities. You should always check that okay, there should not be any anonymous access or hack could be happen on your product or something. So that feature also is given by GitLab, so you can check your project against your vulnerabilities and smells, code smells, you can say bugs and all. Then we have the operations. So operations have lots of features like metrics, logs, tracing, error tracking, alerts, incident. So these are all I can say in a sum up way that okay, metrics is a graph area, then you have a line by line logs about your operations, what you are doing while doing your building it via CI/CD or whatever you are doing. Then the error tracking, for example, if your pipeline is running, you face some errors and there was error due to which your build fails or deployment fails, then you can have a error tracking in the operation section, and you can review okay, what kind of error was encountered. Alerts is something like, for example, your pipeline runs on some scheduled time, and it encountered some error. So this alert, what will do, okay, if error comes in, it will send a particular email, can trigger an email, or trigger any event which can provide an alert to the admins, okay, the pipeline failed or something error occurred while during the pipeline configuration or pipeline run. Then we have incidents like when we have a product, we have an incident. So for example, it can happen that the product which is launched may have incident trace, so we can log those incidents here, and we can come and just check okay, what are the incidents have been raised against our product, and we can quickly have a look at it. Then we have serverless. So serverless is a feature where you write a short snippet of functions which are being invoked at particular time or whenever required to execute or perform some task or operations. So serverless is one of the functions which do not require any runtime compute. They just run without any compute engine. and these are some small functions that perform several tasks. Then we say Terraform. So Terraform is a technology, so which helps you, to write these functions, and you can develop the pipeline also using the Terraform. So Terraform is one of the technology like Java and Python. Then we will say Kubernetes. So Kubernetes is nothing. It's a cluster where you deploy lots of containers. So like in this current going foundation, the most of the deployments are being done on containers. So containers is a very good topic to discuss, and a good topic to explore. We would be covering those topics as well, but yeah, these containers are a group of lots of containers which gets deployed into a one cluster. So cluster is handling those containers, and this gives your system a very high availability, and and provides you a very good efficiency performance for your project, or you can say a product. Then we will talk about the environment. So like every project has different environments like dev, test, production, launch, pre-launch, staging. So like that way we have lots of environments, so you can configure those environments into the GitLab, and uh, so you can detect the changes for each of the environments. So feature flag is nothing, just whatever the feature you have developed, you can just flag them. Okay, uh, in this particular commit, this was the feature developed, so you can flag those features. So that is just a small. Then we can say about the package and registries. So package registries are something where manages your packages and also their registry. So likewise, we have two options. The first one is the package registry. So package registry is uh, registry where maintain lots of other libraries and their packages. Like Java is based on Maven, so you have Maven dependencies, so these are also libraries and the packages. The same way Node has npm packages, the Python has PyPI packages. So these are the packages which you can manage within the GitLab itself, so you do not need to reach every time internet and get those packages while building your project via pipeline. So you can import those packages here, and pipeline itself can read those packages from this registry. Then we have the container registry. So as I already said that today we are almost moving towards the container deployments, because this gives you more high availability, and lots of spaces to deploy your uh, product very efficiently and gives lots of good performance. So container registry is something where maintains your container images. Like container needs an image to be deployed. So for example, that image is something which is incorporated with the OS, your product, or you can say your code, which is built and deployed on that OS, and we combine that OS and product, and we merge it, and we make an image, and that image can be used by any container. We can deploy it on any container within the cluster. So here GitLab has provided us the registry, so we can maintain our images within this registry, and when the pipeline runs, can read, or can pull or push the image within the registry and can deploy it on containerized services. Then we have analytics section. So analytics section is nothing, just giving you a high level of graphical, or you can say analytic data, that okay, how many pipeline runs, then total success for the pipeline, total failure for the pipelines, and about the repository, the same, that okay, what kind of language have been used for the code. Like here I see Java as my 100% use, so I didn't have used any other technologies right now, so it says Java is 100%. Then you see commits, that okay, there were 3 commits, average 1.5 commits per day, there is only one author. So these kind of analytics, you can just have it look here, and you can analyze your repositories, different behavior and activities. Then you have a wiki. So wiki is something where you can write lots of documentation about your project. So this is one of the major activity which I think every project owner should follow. Like for example, you have a project which is running for over more than a year. and then you need to maintain those documentation for that product. So at any point of time, if any newcomers joins to your team or your GitLab repository, they can just refer to this documentation and just can understand about your project and about your product. So that is where you can write lots of documentation. Then we have a snippet section. So snippet section is nothing like we develop lots of code pieces, and there are some complex, very, very complex code pieces. Now, we cannot write lots of elaboration and lots of text within the code itself. So what we do, we snip that code from the repository, and we can put it inside the code snippets with its documentation. Okay, this code perform this particular task, this, whatever you want, you can just document against that snippet. So any point of time, if anyone found any error in that code and wants to solve it, so first need to understand what it does, how it works. So can read this documentation for the code snippet, can make him understand more accurately, and would help him to fix any errors or problems coming in later future. Then we have the members section. So member section, we have two types: to invite a member and a group. So you can invite a single member as well as your groups. So you can just write the email address or your GitLab members unique ID, and then you can choose role for them and their expiration. So expiration is the time for which you provide the GitLab access to your repository for the time. Then we have role. So we have 4 kinds of role. The maintainer being the highest one, so you give all the accesses for your repository when you assign a role maintainer. The developer is the role which gives only certain level of accesses, where a developer can just pull or push or develop something on some specific branches. Then we have reporter. So reporter is only the read-only mode, where user can come and navigate to the branches, navigate to the other options, look at the CIC, and just read it, and or can walk through your repository. The guest is something where it's very high level. You can say just on who can just have a look at your repository, and that's all. So these are the 4 levels of roles you can assign to a particular user. Then we have the settings. So general settings like, okay, your project avatar, or you can say your project name. Then you say its visibility like private, public, and its permissions. Then you say merge request. Okay, so in the merge request you say, okay, how much commit should happen, fast forward merge, or there are lots of merge ways. So fast forward and also other ways, we will discuss about these. So you can configure your merge accordingly. Then you have badges, like, okay, what kind of badges you configure for your project. And also you have some service desk. So this is an help, like for example, if you require any help, you can just connect to your GitLab support bot or something. And then you have an advanced options. Housekeeping is something where in order that, like, if you want to move a new instance or something, so GitLab housekeeping works you for that. So you can make it quickly move, export your all the things, and it's ready. Then you can archive your project. You can zip it into some archive and get all the things like issues, comments, and everything. You can change your repository path here as well, like, okay, at what path it should be available. If you want to transfer your project, so you just quickly have to choose the object. Okay, I want to move my group my_java to some other project, like that way. And finally you have delete option. Probably you should not delete your project if it's very important. So this access should be a very limited one. Okay, then moves to the integration section. So integration is something like I already said. We have lots of issue trackers like Jira, HipChat, and these are the listed. You can see lots of issue trackers. So you can integrate those issue trackers with the GitLab. You actually track those issues against your GitLab code being updated. Then you have the webhooks. So webhooks is something which listens to the changes and triggers something. So for example, if any pushes happen to master branch, I would trigger the event this. If a pull has happened to our master branch, then we will trigger this event. So this is where webhooks come into an action. Then we have the repository option. So like always, we should have one default branch which cannot be deleted. So in our scenario, the master branch is the default one, because whenever you create a new repository, the master branch is always the default one. You can make any branch a default, but that branch cannot be deleted. So for example, if you have any production branch, you can select that branch from here and save the changes. Now that branch becomes your default branch and it cannot be deleted. So that is how you can change your default branch. Then you have the mirroring repository. Now this option is very much important. Like for example, you have a GitLab server one where you have kept your code. Now for example, accidentally that server goes down. Now it's very hard for you to get your code on the fly. So this is the way you can create two repositories for your project, one at some location and one at some other location, and then you can mirror this repository to that. So at any point of time, if your GitLab server one goes down, you can access the other repository and you can get the latest code and everything from there. So this is where mirror repository helps you. Then you have protected branch. So you can mark your branches as protected. So once it's protected, so you can configure about their merge and push. So for example, like master branch is allowed to merge and push only by maintainers. So developers, reporters, and guests will not be able to do anything in this master branch. They can only read it. That's it. So like that way, you can restrict the roles according to their branches. So you can see I just had developers plus maintainer or no one. So this way you can protect your branches. So you can say like limited access to creating and updating the tags. So like we can have protected tags. So you limit those tagging. Like I already said, you can tag your releases. So that way you can limit for tagging. Then we have deployed tokens, keys, and cleanup. So repository cleanup is something which runs on you can configure it in such a way that clean up your repository for the files which are not required, or something like that way that free up your space. Deploy tokens and keys is something which you get a unique token or a key which provides you a read only or write to only access from any different tool or from different location, and that can be used for the deployment or some kind of that behavior. Moving to the CI/CD. So CI/CD, we have a general pipeline, so you can customize your pipeline configuration over here. Like okay, pipeline status, and how it should follow, like git fetch, then what would be the timeout, then okay, what would be the configurable path for my GitLab YAML file. So this way you can configure about your CI/CD file. And then we have auto DevOps feature. So auto DevOps feature is something which is predefined continuous integration delivery provided by GitLab. So when you choose this option, it will quickly move you through and prepare an automatic pipeline which will ask you some of the inputs, and after based on that it will prepare some sample pipeline which you can reuse for your deployments and that purpose. Then we have the runner. So this is one of the best thing that requires in the CI/CD. So CI/CD, when you run or create the pipelines, the runners are the best part of it. So runners are the actually you can say the invokers. You can say I can say that gets the details from your branches like master, production, or whatever. They get these source codes, they go to the GitLab server, they do several tasks according to the script you have written, and then they do certain tasks. So this runner helps you a lot on this running those tasks on GitLab server, and then making it and moving your output result to some artifact location or something like that way. So runners are the best part of your CI/CD. Then we have variables. So variables are nothing, just an environmental variable. So like every system or every technology needs to have those environment variables. So likewise, the same way you can configure environment variables for your GitLab repository. So for example, any CI/CD or pipeline runs, they require something which is always required. So you can configure them as an environment variable. So your during the run of your pipeline, it can read it from those environment and can extract and use them. And it can also varies according to your environments like dev, test, prod. Then we have pipeline triggers. So pipeline triggers is something which forces your pipeline to get triggered. So it can be some action or API call which says, okay, trigger the pipeline. So these are also based on your project permissions and um, also levels of accesses. Then we have cleanup policy for tags. Like for you mark tag your container registries, your releases. You can also follow those cleanup policy so you get more space out of it, whatever is not required. Then deploy freezes is something when when you say when deployments are not allowed for the environment. For example, you have dev, test, and prod, and you say, okay, prod deployment should not be triggered before December 2020. So it would be like that way. So now it will take like I would say that okay, my production deployment should not happen before 20 December 2020. So till that time, even though if you push code or merge it, it will not trigger the deployment. So that is the good feature which is being given by the GitLab, I would say. Then we have the operations. So same, you can do lots of settings about your alerts, incidents, error tracking. Okay, how it should look like, and the authentication token, so you can read it from any outside, even though without locking your GitLab or something. So you can do lots of features. We can expand. Then if you want to host your static website, so for example, if you have one page static website, you can host it within the GitLab. So they say, okay, you get the domain, host your one page application. It should be static application, and you can have a look at it. Audit event is something good because you need to keep track of your past project development. It can be long going project, so audit is the best thing. You should have it in your project. So I think that is all from this particular I would say that these were the few features we discussed, and we will also most probably learn how to use those features in the upcoming videos, and we will also deep dive them. If you feel any good suggestions or something like, okay, I need more, I want to explain them more, and if you face something difficulty, please do provide comments on that, and I would be looking them, and maybe I would cover them in our next videos, and that would probably help me also to understand the level I should go and explain it. Thank you all for this tutorial, and please do subscribe and share as much you can. All support is needed from your end, because the more you make it a share it, the more people subscribe it. It would help me a lot to bring more new kind of videos which would be more interesting and or learning. Thank you all.
In the previously, we covered the features of GitLab theoretical way, and in this tutorial, we will have practical implementation of one of them, and this session is gonna be interesting. But before we begin, if you are a beginner to GitLab, you're looking for best practices and standards, then you are on the right platform. I will always guide you through the best practices and the standards that has to be taken care during the GitLab development. Okay, so before guys, I would like you all to subscribe my channel for any new updates, any new videos or topics that I would be covering. Would like you all to subscribe it and share it. All support is needed from your end. And for my Indian friends, दबा दो यार, सब्सक्राइब बटन को ना प्रेस कर दो, प्रमोट करो यार चैनल को, बहुत मदद होगी. Okay, so let's get started. So first I will navigate to my GitLab account where I have created already a group and a project. I will go inside my repository. Okay, and then I will move back to the repository section. So earlier we created this project and we had one branch master. So let's move to our agenda. So today agenda will be to discuss about Git branch strategy and its creation from GUI as well as from command line. So Git branch strategy is something where you strategize your development.
Like there are lots of other subversions which are based on single branching strategy, but with single branching it's very difficult for end developers to work, and also to move your developed application or your product to your production environment, because managing it on just on single branch is very difficult. Based on that, to overcome that situation, GitLab made its tool to work on multi-branch strategy. So for example, if there are two developers working, they can have their own separate two branches. They can develop whatever they want on their own branches, and then they can raise a request to get it into one branch. That is how we reduce the conflicts. We reduce the interdependency of one of the developer to another, and that gives lots of easiness for your applications to work in. And the main thing is it saves a lot of time. So today we will be thinking about the GitLab strategy. And like currently in my existing tutorial, you see I have only a master branch. So by default, GitLab repository comes with a master branch. I would like to create two more branches into it. So one would be the staging and another would be the production. So master is the default one. The staging branch is something where I would like every developers to develop and push their codes and test it. So this stage is just for development purpose. So developers are gonna do lots of development, fixing, bug fixing, some logical changes. All the things would be happening in my staging branch, and it would be deployed on my test server, so we can test it internally. Once we finalize that, okay, staging area is working fine, we can move that staging branch code to our production branch code, and from production we will move it to production server, means we will deploy it. So now my production branch is always safe with any kind of change, because every developer would be working only on staging branch, not on production branch. Production branch would only be required to deploy the code, or you can say the application code, on the production server, and it will only accept the code from my staging branch. Once we had a deployment on production branch, we will move that code to our master branch. So that says that okay, now the cycle is complete. So branching strategy in Git follows a cyclic movement. So like from master, I would push some initial code into master, and from master I will cut the branch staging. So now from master I will have the staging branch, and from staging I will have the production branch, and from production it will go back to the master. So now this is how I complete my cycle: from master, staging, production, and again master, then staging, production, and then again. So this is how my overall development cycle for Git strategy will be going on. So let's understand these things, and also we will understand about the issue tracker, how we can develop different features, and naming conventions, best standards to move on. So quickly, let's get started. So I have few commands with me ready already for you all, and I would also provide it in description link. You can get it from there, and you can use it for this tutorial and on your personal practice. So I will just quickly go back to my browser. So as you see, I have only master branch and a base code ready on it. Now I will clone this repository with HTTPS. So I will say copy the URL. I will go back to a git bash, and then I will say git clone and my URL. Okay. So we'll take a time. Okay. So now I have cloned it. I will navigate to this master, and you see by default it is on master branch. I will configure my user in it. You can also do it for your GitLab account, that from which user you would be working. So I would be working with my this user. Okay, so I will say configure. Okay, now my user is configured. Now to check how many branches do you have a command git branch. So this is something you would be using to check all the branches. So I will say git branch.
So see, now it says that we have only one branch master, and asterisk means that it you are on that branch. So asterisk says that I am on master branch. Now, before we create any new branch or we do push any changes, it's always a best practice to take a pull from your repository, because that is a best standard that avoids a problems of conflicts or merge, or lots of troubleness from your code. So it's always said that you should always take a git pull before you push anything to the remote repository, or if you want to create a new branch. So first of all, I will just go step by step. So first step is to take the latest update from the master branch. So I will say git pull, git pull. So it says you're already up to date. Now we are ready. Let's go and create the new branch. So the command is git branch and the branch name. So for me, the branch name is staging. So I would say git branch staging. My branch created. If you want to check, you can just type git branch minus I. You see, we have the staging now ready with us. This is the staging. Now, again, this is how you check the status. Then, before we move to the next one, we would first like to create the production branch as well. So I will say git branch production. No, sorry, yeah. And again, I will check the status, and you see now we have both the branches ready and we are active on master branch. Now, if you want to, make any changes to this branch or something or not, or whatever, it depends, but for now I would not make any changes. I would first like it to move it to my report repository. Now if you see, we have these branches on a local, but if you go to the browser and you check, you will not have these branches yet. If you either refresh also, you will not have these branches yet, because we have created those branches locally. Now to push them to the remote branch, you have this command git push minus u origin and the branch name. So I will use this command, and my branch name is staging, and I will say enter. Okay, so it says that staging branch has been pushed. Now if I go to the browser, refresh it, and you see now we have the staging with us, but still we don't have production yet because we need to push it again. So we'll go back. Now we will say production, and we'll say enter. Now my production branch is also here. So if you see, check the remote repository, now we have all the branches with us now, right? So this is how you create your branches from the command line, and based on your branching strategy. Like I would like to have only staging and production, so I would develop and test everything on staging, and then I will production would be for the deployment and keeping track back for my production deployment code. Then let's clear this out. Now if you want to delete these branches, now if you do git branch, let me see, so you have all the 3 branches ready. Now if you want to delete any of the branch, what you have to do is that you will have to use 2 commands. Now these 2 commands have different purpose. The first command says you have to delete it locally. The other command says that you will delete it remotely. So for deleting it locally, you have to use only just the normal git branch, the -d which says delete, and the branch name. And for a remote, you have to say git push to the origin, and then the command that okay you have to delete and the remote name. So first I would use this command, okay, and I will say the branch name as staging, deleted branch name. Now if I check again, so you see my staging has removed. Now I don't have staging branch now, but if you go to the browser and refresh, you will still see the staging because we have deleted it locally. To delete it from the remote, we have to use this command. So I will say git delete so staging, and I will say enter. So we'll take a couple of seconds. Yep. Now it says that it has been deleted. We'll go refresh the browser. We'll check the drop down. Okay, now we don't have any branch of master, so we will just navigate to the master branches, and you see now we have only master and the production run ready basis. Quickly we will delete the production branch with the same way. So say git branch minus t production, delete it, git push minus u origin and saying production. Oh, I forgot that snippet. Minus minus delete. Sorry. Cool. Now say enter. Deleted. Now if you do locally git branch minus a, it says deleted. Now you have only master branch and you are active on it. And if you go to the browser, refresh it, you see your master branch has gone. Oh, sorry, your production branch gone. So this is how create or delete your branches from command line. Now if you want to create it from GUI, then log into your GitLab, log into your repository, and from the repository section navigate to the branches section. So once you reach on branches, you will see only one default master branch. But before you cut any branch, you should always have a base code ready on your master branch. So if you just go to the file section, you see I have a base code ready here. So quickly going to the branches, and you see this top right, you have a green button says new branch. So you will say new branch, and you will say the name of it like staging, and it should be created from the master, and then say create branch. Cool. Now again branches. Now you see we have two branches ready with us, and if you want to create master, I will say new branch, and I would say production, and you can create it from anywhere, either from master or from staging. For now I will take staging because, as I earlier said, we will be doing a cyclic strategy. So branch, so now it would be something like master staging production, master staging production, again from production to master, then from staging, then again production, then again master. So this is how cyclic I would be going. So you see I have all the three branches now, production and staging, and all of them have same code with them. Now if you make any changes to any of the branch, now these are the figures that tells you that okay, which branch is behind, which branch is ahead. If you hover it, you will see it says 0 commits behind master, 0 commits ahead, and here also it says the same. So it says that you are 0 commits behind master, in the sense you haven't, the master haven't got any update yet that you are behind it, you are on the same level. And it says 0 commit ahead means that you haven't made any update in the staging branch or the production branch, which are not present in the master branch. So these figures tells us. So if you want to see this change, overdo it right now here. So I will go back to the staging branch, and also I will update this readme.md file, and I will add just one dot here, and we'll just commit it. Okay, now let's get back to the branches, and you see now there should be one figure. So you see now it says that you are one commit ahead. So it says that the change you have it on the staging branch is not present on the master branch. So once you move that change to your master branch, this one will again become 0. So this is how you keep track what are the current changes are present in the staging with the figure count. And if you want more in detail, you can just go to the commits section, and you can select any branch like staging, and you see this was my last change. The same way you can check it in detail, whatever you want. So let's quickly get to the branches again. Now I want to delete these branches again. Now to delete, we just need to navigate to the branches, and then you need to just press this red highlighted button. So I will say delete, I would take while. Okay, my branch is deleted now. Now again, I will say for protection also delete, and it says deleted. So this is how you create and delete the branch from GUI and from the command line. Now we will create back again those branches because I will be going ahead with your study. So I will just quickly create them again. Staging, master, and then I will say create one more branch, production from staging. Good. Now I will get these branches on my local repository. So go to the git bash, clear this old stuff out. Now I will say git branch -a. Now if you do git branch -a, you don't have those branches yet in here, but you have it on your remote repository because you haven't made any update. So it's always recommended to have a git pull command run whenever you create any new branch on the remote repository or you are going to push anything from local to remote. So it's always a good practice to use git pull before you push or you create anything new on the remote. So I will say git pull. Okay, now it says that two new branches have come in, that is production and the staging. So now if you say git branch -a, now you see we have all the three branches with us and we are active on master. To change the branch or to switch between the branches, you have a command called git checkout and the branch name. So I will say staging and enter. Now it says you can see that ref cursor has changed to the staging area. The same way you can say production and you will move to production. And again, the same way you will say the master. Now you are on master branch. The same way, sorry. Now you see we are all here. Now it's always recommended to pull the new changes always from repository on the master branch. So like for example, if you want to get any changes, you should always check out to the master and then you should pull and then you should switch back to your default branch. So we are ready with our branch setup. Now we will move to our next thing, that is the issue tracking. So like for example, this was the strategy that needs to be initially set while you set up your GitLab and its branches. Now we will go into development area. So like this is one of the issue tracker I have created. So you have issue trackers like HipChat, Jira, and other various tool wiki. So these type of issue trackers are available. So currently I will tell the usage of those trackers later in some other tutorials, but for now I just have two created sections here right now, so I can actually explain you about this. So the first we have it, the story. So every issue tracker has a definition that okay, what kind of feature you are going to develop, whether it's a story or it could be a bug. So story where you develop something new, and bug is something which you have developed and it does not work appropriately up to 100%. So then we say it as a bug. So I have created an issue tracker where I will develop a story and one of its bug. So it says it has a unique ID IT007 and its description is add below text to readme.md. So my task is to add this text to the readme.md file and its unique ID is this. The same way, the bug says that IT010 description text in the README file does not contain full stop at last, update as below. This is my new story. So this is not the right now feature. This will come into later, but first we need to do this. So before we do, it's always recommended that you do not make any changes to your master branch, staging or protection. So you can prohibit developers to do that by going to your settings and your repository. Once you navigate here, you have this protected branches section. So you can select the branch like staging and then you can say okay, who all or can merge it. So I will say developers and maintainers, and who are allowed to push? Developers and maintainers. So this is how you restrict that. Okay, on the staging only developers and maintainers are allowed to push, or you can, if you have any users, you will be listed with those users, so you can select particular users. If you have 10 users, you can select out of 10 5 users who can push or merge from in the staging. So for now I will skip this one. We'll go back, and now so it says that I have to do this. So what I will do is that I will get back here. I will go back to my staging, because as I said, staging would be my development area and my testing area. I will say cat readme file. So I will check my old content. So it says this is my first Git tutorial. So it has this content which has to be changed to this one. Now it's always a best practice that you name your branch so you can actually relate it with your issue tracker. So likewise, you see here we have a unique ID, that is IT007, and story means it's a feature. So you are giving some feature to your product, so you can use a prefix such a way that you can identify it. So I will say we can say it as feature, or maybe FTR, right? Or it can be story. So this is how you prefix it. Then after this you use slash coming inside, and you need to tell the unique ID. So I'd say, so it's always recommended to use that unique ID which is being provided by your issue tracker. So if you have Jira, and then it would be Jira and hyphen something number. Then if you have hip chat, then whatever the project name underscore your unique ID. So this is how I should create my branches, which exactly I'm going to develop. So this makes us easy for to keep track by looking at the history. So I would create the branch, new branch. I would say it as ftr slash it007. This would be my branch name. So I would get back to my, I'll copy it. I'll get back to my this one, and I will say git branch and my branch name. Cool. So there's no hyphen missing. I will say hyphen, and I will say enter. So now if I check git branch minus a, oh, I have that branch ready with me. Now I will make some changes to it. So if I say I will navigate to that branch, I will say git checkout ftr 007. Now I am on that branch. Now I will see readme file. So we have this command. Now we have to update it. I will say readme.md. Okay, we need to change the content. So I will get this content from here, and now I'll update it. We'll remove this, insert, no, sorry, paste. Okay, so my content updated. Now I will save it, and I will again do cat. Now you see my new comment has been updated. So I have developed this feature. Now I will move this feature to my remote repository. So for that, as I already said, you have certain commands which I have already said. So you need to push your feature, so you will use this command. I will get this, and then my branch name ftr007, enter. It will take quite a couple of seconds. Yep, updated. Refresh your browser, and you see now we have that ftr-it007 branch ready with us. Now if you just see that on master your comment remains the same, on your production same, but in your this branch it has changed. Sorry, it haven't changed it yet, because we have just pushed the branch right now. We haven't updated our branch. So we all the branches have same, but in this branch also you have just the same one, because you have just created the branch. We haven't updated our changed changes what we made. So you see it's still on the local. So if I say git status, right, now we will add this git dot commit, then story id 007 developed, commit, destroy, sorry for my spelling mistake, and git push. Okay, now I have posted. Now once I go and refresh it, and you see I have my change in this branch, but still if I check my staging and all, I will not see that change yet. Okay, so it's on my branch. So we made push to our feature branch, and I will quickly merge it to my staging. The merging concept we will be covering later in tutorial, but we will have the merge at the back now. So as you can see, I have already merged uh, the changes we made on the feature branch, and it's it on my staging branch. So I have select my staging branch, and I can see my new change here. Now we'll quickly back to my git bash. I will clear it, and as you see my development is done. Now I need to delete this branch, so I will go back to git, check out my master branch, and then I will say git pull, and now I will delete this branch. So I will say git sort, I will say git branch delete ftr. Okay, it says deleted. I'll say git -a. So you see the branch is deleted, but it's still on my remote repository. Then I will delete it from my report as well. So git delete sort, and I will say ftr it 007 delete. Okay, it is not deleted from the remote branch also, or remote repository. So you see now the branch is not yet present, but we have our change on the staging now. Now this while on staging, it get deployed on some server, test server. Now it will be tested. So we will see these stuffs later very much when we cover those concepts. So for now, if this has been developed and in the issue tracker there comes an issue, and it says that there is a bug IT010, this is the unique ID, and its description says the text in readme file does not contain full stop, at last update as below. So it says the story or the feature we developed was right, but we missed the full stop. So for this, a bug has been raised in the tracker. So for this is the ID. Now we need to update it. So again, we will be following the same concept. We'll say first git pull, and we'll say git branch. Now I will not say ftr because it's not feature, it's a bug. So I will say git branch bug slash, my ticket number was this one. So I will say IT-010. Okay, now if I say git branch -a, you see I have that branch. Now I will check out to that branch, check out back. Okay, now I am on that branch. Now I will push this branch to the remote repository. For that I will be using this way. We'll paste it here. Now we'll say back push. Now we'll take a while, and if you go back to the browser, refresh it, you see now the bug IT01 is present now, right? Now we'll make the change in the file. So I will say vi, or instead of vi I will say echo. Now we'll put that text, So I keep insert, okay, and then I will say readme.md file. Enter. Now I will say cat readme.md file, and now you see we have the text ready with the full stop in it. We'll push this, get, and we will check the status first. So it says that this file has modified and need to be pushed. So I will say git add dot, then I will say git commit -m bug fixed. So some comment and get push. Okay, so navigating back, refresh. Going to the branch, and you see this is my new story. So we have this dot now ready with us. Now this can be merged with your again staging, and it will go and get deployed on dev, and then you can test it. So this is how categorize your branch name as a best practice and a best standard, that okay, if you're developing any feature, it should be something like feature, FTR, a story, and then your unique IT ticket number. It could be any agile. It means in say you can say when we follow agile pattern nowadays, we follow it. So you can in that ways these tools develop sequentially and generate some unique ID against each of the development phase. So this is some unique ID that every issue tracker would have, and if it's a best practice that you should always use those. So in reference, when you go and you refer to the commits, so you can eventually, if I just the staging, you see in history I can see, yeah, stroy, sorry, FTR IT007. So I can I can see that okay, the feature IT007, this was the merge request, and then I can click on it and I can check whatever things was developed, what things were developed. So this keeps us easy to detect all the changes in remote repository for any past changes or history. So this is how it's best practice to go on this way, I would say. I think we have covered a good overall about the Git branching strategy, creation from GUI, from command line. We also uh, created and updated some files on branches. We also covered how issue tracker, a little bit on issue tracker concept, and how you name your branches with the best standard, if it's a bug or it's a feature. So how do you name your branch, how you categorize it, how you push it, and then merge it for staging. But for merge more concept, I would be covering in my next tutorial about the merging concept. That would make you more clear about it. And that is all for this tutorial, I think. We will meet in the next tutorial with another concept on GitLab. If you have any comments or feedback, do provide it. Thank you all for this tutorial. Please subscribe and share as much. Today we will be covering one more feature of GitLab that would be more interesting, and we will be doing lots of practical stuff today. Before we begin, I hope you are enjoying my old tutorials which I have already published, and you might be having good time in learning the GitLab. If you face any issues or any challenge or any kind of questions that are coming to your mind regarding the GitLab till now, you can post your questions, doubts, or maybe whatever you require against it. You can just post a comment on my videos, so that would help me to cover those questions and answer your doubts or clarification, or if you need more detail about it, that would really help me to provide you the best tutorial and the best answers against your questions. So please do comments if you have any questions around it. So today I have a very hot topic that many of the developers during the project development, or you can say product development, they faces a lot this kind of situation. Now this situation is very small, but due to missing best standards and the best practices, this issue becomes a very big. So today I will walk you through those best steps and best standards that will avoid this situation to come in, which make consumes a lot of time for developers to solve it sometimes. Okay, let's quickly go to our agenda. Today we will learn about the GitLab merge request and the code merge with two developers. So I will walk you through the feature of merge request that is present on the GitLab. So you can see on the left hand side, this is merge request. So we will be learning about this feature. And apart from that, I will show you if there are two developers working on the same code base, how they can update their own code base and then push their developed code. And if they face any difficulties like in conflict, like any one of the developer has pushed something and another developer was still developing, and now that one developer who was developing has to take the code that has been pushed by the other developer, and then it becomes a conflict, how to merge that code with the latest one. So these all concepts would be taking. So here I will take two sample developers, but in the current, or you guys were like in real time, there are lots of developers. So I have prepared a set of instructions for each of them. First, let's go with the merge request section. So merge request is something where many developers develop the code base at their own end and their own single branch, and then request an approver or maybe GitLab owner or repository owner to merge their request or maybe merge their code which they have developed on their branch to some parent branch, or maybe I would say some head branch. So like for example, in our tutorials, I have made a branch like master, then staging, then production, then again master. So every development and testing would be happening at the staging branch, and then finally it would be moving to the production branch for deployment, and then once we had a final deployment, it would be coming back to the master branch. So this is how my branching strategy is going on. So for the merge request, like if there is any developer wants to develop something, then they should have to push their changes to their respective branch, and then they will request an approver to approve their request and move their changes to staging branch. So that is all we will learn in this tutorial. So let's quickly get started with the practical. So what I have to do is that first step, we need to create a new branch from the staging branch and name it as FTRIT008. And that's pretty simple, as already explained. So this is my GitLab repository. I will go back inside my repository, and then as you can see, I have only 3 branches till now. I will go back here, create branch. Now I'll name it at FTR, and then I will say from the staging, create the branch. Yep, my branch is ready. Now I have to check out master and git pull. So as I already said, if you have an existing repository already cloned on your system and you create any new branch or maybe feature branch or bug branch, then you need to navigate to your master, then you should pull it or to update your local repository. But in my scenario, I have not yet any repository here, so I will start it from my clone. I will clone it on my local system, git clone. Yep, already get clone. Till the time it get clone, I need to check out this feature branch which I have created. So I will check out this branch. So yep, repository is clone. I will get into it. If I'm on master branch, then I will say git check out and FTR. Yeah, now I am on my branch. Now what I have to do is that I have to modify readme.md file with the text as this is merge request for IT008 to staging. We'll get this text, go here, open readme.md file, or maybe I could say echo. Yep. And readme.name updated. I will check the content once. Yep, my content is updated now. As a next step, I need to perform git add commit pull push to my branch. So say git add dot git commit -m, and I would say my IT 008 development. Okay, so I forgot to configure my user config user.name. Okay, at the rate gmail.com. Right, now I have my user config. I will say commit, and finally I would say push. Okay, so far we have updated the readme file and we have pushed changed to the remote repository. So if I refresh here, so you see our readme file is updated on the feature branch, but still we do not have change yet on the staging branch. So for this I would be creating a merge request. So as the next step, I have to open a merge request to a staging. So as you can see, once you commit the code, you will see this blue button here which says click merge request. Either you can start creating your merge request from this blue button, or either you can go to the repository, then on the branches, and when you see all the list of branches against the feature branch which you have created, you see the merge request or compare. So merge request is the option, so you can start your merge request from any of the one. So I will start it from now. Here I will say merge request. Okay, so this is what somewhat it would look like when you start a new merge request. So it says that from feature branch into master. So it says that your current feature branch will be merged into master, and as I said, that master will not be updated directly, it should be updated after production. So currently we need to move this change to staging. So I will change the branch here. I will click on it. So on the left hand side you have the source branch. So source branch would be your feature branch, and the target branch should be your staging branch. And I say compare, and then you can provide some titles. For me it's all right with this way, and then you can describe some description that okay, what change is there in this merge request. I say there is an update in readme file. So I would say that you should provide these descriptions and title, because when you want to do audit or you want to check your history, then these merge request fulfillment brings you easy way to analyze that okay, what all sort of changes were there in particular merge request. So that makes it easy when you go back in the history, or if there is an issue when you have already merged something. So that makes you easy. So I would like you all to go with the title, description, proper description, that everything should be captured in it. Then you have an assignee section, so you need to assign your request to a particular user. So it could be, you can say like GitLab repository owner, or maybe I would say maintainers. So you have to assign this request to them. So currently I have just one user as a maintainer, so I would assign this request to them. Then you have a milestone and labels. So if any of the repository owner have configured a milestone and labels, then you can choose it from the drop down, the milestone and the labels. Currently I don't have, so I will skip it. Then you have two merge options here. Two checkboxes are here. The one is delete source branch when request is accepted, and squash commits when merge request is accepted. So delete source branch is something which will is that your source branch is your feature branch. So after the merge request has approved, this will automatically be deleted. But as a best practice, I would suggest to untick every time, because maybe it could happen that in the merge request may some error comes, or maybe going forward up 2 or 3 days you want that branch again, or maybe you want to review the code again after a successful merge also. And if you delete the branch, then you don't have any trace back to get back that branch. So it's always recommended and best practice that you should not delete the branch at the time of merge request. You should delete it after some period of time. So it could be any, but yeah, not on the same time when you are merging it. Squash commit is something when you say that when the merge request would be accepted, the commits what you had on branch would be wiped out. So it is always said that we should not also tick this checkbox either. So try not to check both the boxes, and then you have to click on this green button and say submit merge request. So once you submit your merge request, the particular approver whom to ever the request was assigned, when he navigates to his merge request section from the left hand page side, you would see some page somewhat like this way, and you see here one merge request is pending on that. So it says that okay, my IT008 development was assigned to a user and it has to be merged to the staging branch. So this is what the merge request looks like. So a particular approval will go inside and we'll see this stuff. So it says okay, request is to merge feature branch into staging, then this approval is required. So this is optional also, and this can be mandatory as well. That depends on the owner of the repository, how are they planning it. So currently it's an optional, but still I can click to approve it. So it's not that only one approval would be there, can be multiple approval. So it does not matter the way you design it, it become, so here can be like 3 approvals, so all the 3 approvals would be required to merge it. So that is how it goes. So I will say approve, and then this is the box where it says merge. So merge is something, now this is the button when you click on merge, then the particular change from the feature branch would be merged into the staging branch, right? And this would be a sort of messages that would be there. Like I always said that every commit has a message. So like when you merge something, it will generate this message automated. You can even modify this if you want. Then you have dislike, or maybe whatever you want to add a reaction for this particular merge request, or if you have any comments to share, you can add it here itself. So you will say okay, it looks fine. So like you can add this comment and you can say comment. Okay, so comment edit. Once you add it, once you're ready with all the stuff you have done, now if you go back to the staging, you see still I don't have those changes here yet. Now I'll say merge. Okay, now you see that says merged by username, then changes were merged into staging with this ID. Now this is the commit ID, which is unique across all the GitLab, and this uniqueness maintains your every commit record ID. Now you see the request is merged successfully, and now if I go and refresh it, and you can see that in the staging branch I have that change which I have made on my feature branch. So that is how you approve the merge request, and it gets merged. You see merged written also over there, and now you have the change. So let's get back. So assign it to approver, and once get merged, you will see the changes on staging branch. This is so already done. Now after successful merge, keep your feature branch for 1 week. So I would say as a best practice, you should always keep your feature branch or bug branch for at least 1 week, till the time it gets tested by various levels. So you can actually keep if there is any issue, you can actually look into the branch itself. So I would say recommended should be 1 week, and then you can delete it. So for now I will go and delete it right away because I do not need it for any purpose anymore. So we'll go navigate to the branches section. I can see my FTR YT008, and we'll click on this delete button, and I'll say okay. Okay, so now my branch is deleted. So far we covered all the aspect of merge request, how it happens from time of creating the branch, and till deleting the branch and approving all the request and moving it to staging branch. So this is so far is all around for the merge request. Let's move to the another section, that is code merge. Now code merge is a section where main developers develop the code at their end, then they push it into the repository, push every day. This happens at the point of time. It is sometimes becomes a conflict for 2 or 3 developers together, that maybe one of them have developed before and pushed, then for the developer becomes a conflict, then need to solve it. So we will talk about the code merge, how we can solve those code issues if there is any conflict or something, and also the best practice to follow for this code merge strategy. So we'll quickly go back and we'll go back to the staging area. Okay, so what we have to do right now, we have to create two new branches from staging and name it as demo developer 1 and demo developer 2. So I will give this name. Go here, I'll create new branch and I will say demo developer 1 from staging. Create the branch. Cool. So I have demo developer 1 branch ready with me. Now we'll go back, I'll say new branch and I will select staging and then I will select 2 demo developer 2. Get the branch. Okay, now I have demo developer 1 and demo developer 2. All are same at the moment right now. Let's get back. Now, as I said that you need to get your repository, or if you don't have it already, then you need to clone it. If you have already, you need to check out the master, then you should update your repository, right? Now what I have to do here, in the sense, now I do not have two systems right now, so what I will do, I will create two folders or into the same system but at different locations. So I have two different repositories on my local and it would act somewhat like two developers. So I will check out demo developer 1 in one location and demo developer 2 branch in another location. So let's quickly get in here in the git bash. I will navigate outside. I will clear. So if I check my current directory, so I have already repository, I will clear this repository entirely. Cool. Now if I check, now I do not have any repository here. And I will make one folder. I will say name it as dev1. I will make another folder and name it as dev2. So now I have two systems named as dev1 and dev2. Now I will navigate to dev1. Here I will clone the repository. Git clone. Should I get the clone URL? Cool. Git clone. Yep, cloning done. So I will navigate in. So I have one master. I will configure my user here. Configure. Now I will navigate back. Now we'll go back to the developer 2 and again I will clone it. Yep, git clone. Okay, cloning done. Then I will move inside and then I will configure my user. Okay, so we have created two directories and if I check, I have dev1, dev2. Inside each of them I have a separate repository itself. Now so I have demo. I have already now have the repository on my local system. Let's get next. What I have to do, make a change to the readme file, add commit pull push to demo developer. So let's quickly make some change in developer 1. We'll go back here. So I will do git check out demo developer 1. Yep. Now we'll make some change in the readme file. So this was our last change which we have made. We'll change it to, this is the change developer, this is the change of developer 1. I'll name it that way and I will save it. Cool. I will re-verify. Yep, the change is here. Now let's add commit pull push and then raise a merge request. So these two steps we'll be doing it together. Was I get dot commit -m developer 1 change. Cool. Push. Okay, so change has been pushed to the remote repository. Let's get refresh. So it says developer one has updated right now. So if I go to the developer one, I can see the update in the readme file. Now I will open a merge request from here. I will change the branch because my changes should go on to staging first. So I'll move to staging, then I will compare the branch. I will write some description, update readme, as I updated readme. I will assign it to Maya. I will not delete the branch, and I will say some merge request. Yep. Now again, needs an approval, and then merge it. I say merge it. Cool. So merged. Now if I get back here on the staging branch, you see the change is here on the staging. But if I go to the demo developer 2, I still have the old readme file, right? Because developer 2 is working and does not know about the change yet. So that's definitely fine. Let's go. What we have to do next, we have to go to the demo developer 2 branch and make changes to the readme file at the same location as of developer branch. So accidentally it could happen that the line changed by developer 1, also the same line developer 2 has made the change. So we would be making that scenario here. So we will be going cd dot dot. I will be getting out of this developer 1. I will be going to developer 2. All checkout demo developer 2. Right now we'll edit readme file. Yep, that is the line, and I will change here. This is the change of developer 2. Right now we'll save this change, re-verify. Yep, so our change is present. Now what we have to do, we have to again add pull and same as of developer 1. Say git add dot git commit -m, then I will say developer 2 change cool and git push. So finally we pushed our change in the developer 2 branch. Let's quickly go and refresh the browser. Yep, we can see the change here now. So developer 2 change is present on our developer 2 branch. As a part of next, we will raise a merge request, same as if of developer 1, but there is one update. Now you will see a conflict which will not allow you to merge. So what does it mean? It says that now if you develop if your developer 2 branch will be raised as a merge request to the staging, you will not see the merge button enabled. Why so? We'll let you know. Updated readme sign to Maya. So if I now navigate here and you see the merge button, which was enabled for the earlier request, is now disabled for this developer 2. Why? Because the changes which have been pushed by developer 1 on the staging branch are not yet consumed by, or maybe you can say updated by, the developer 2 in its request, and due to which it says there is a conflict. Now why conflict says, because Git is not able to solve that which developer's code to be key, be the developer 1 or developer 2, so it gets confused out of it. And this is the scenario which always encounters for many times to many developers to, and this becomes a very cocky process. Then you will either have to close the merge request, or maybe you have to solve it here and then reassign this merge request again. So this becomes a very trouble procedure. To avoid these such kind of scenarios, we follow a best practice that gives you a better way that you can even avoid these such situations. So what are these best practices? Let's have a look. Let's see how to avoid these situations. So first I will cancel the merge request which I have already raised. So I will say close the merge request. Okay, I closed it. Now I will go back to the git bash and git pull. Now as I said that this command has to be always taken care, like always what actually developers do, they add, commit and push. They do not take pull in between. So that is the reason where this conflict, if they had made a pull beforehand before they push, then I think these kind of issues would never arise in that. So this is the best practice, that you should follow the sequence: add, commit, pull, push. So let's get back here. What I have to do as the next part, I have to make a git pull. So I will say git pull. Yep. So it says there was an update in the remote repository on the branches developer one and the staging. So that was the change that developer one has made on that. That was not yet present on your local branch, but now it's on your local branch. Now what I have to do, I have to use this command, that is git merge, and from which branch you want to merge your local branch. So my developer2 branch has to be merged with the staging, because ultimately it is going to be merged with the staging. So I need to incorporate all the changes which are present in staging currently. So I will say git merge and origin/staging, and I will say this way. So it says auto merging readme md conflict, merge conflict in readme md. So what happens whenever there is a merge request, Git itself tries automatically to solve that conflict, but if it's not able to, then it says that you need to solve that conflict manually. Now if you see in the front of our branch name, there with the pipe symbol comes the text as merging. Now it says that you are on merging status. Now you will first have to solve the conflicts, and then only you can move ahead. Now what I've not we will be doing, we will be opening up an editor, solving the conflict, save and exit. So it says that there is a conflict in readme.md. So if you have a conflict on multiple files, it will list all the files and you will have to navigate to those files and solve your conflicts manually. So for us, it's only on readme file. So I will just edit my readme.md file, and it would look somewhat like this way. So if you just closely monitor and look, there is some extra snippet came in between, like this head, arrow, 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 then this equals, and then arrow with origin/staging. Now this tells you that the text present between the head and this equal to tells that this is the change which is in your current branch, that is developer2 branch, and the text between the equal to and the arrow with the branch name afterwards, or you can say as a suffix, tells you that this is the change which is on your the branch which name is written here. So now it asks you that, okay, what change do you want in final file, what your final file should look like. So what I will do, I will remove this head first because it's not required in our file. I will remove this equals, and I will remove this as well. Now I can choose whatever the final text I want. So I say I want both the text to be present here. So I would be leaving it like this way, and I will save this file. Now if I say cat readme.md, so you can see in this current branch I have both the changes now, developer1 and developer2 as well. Now still I see it's on merging state. Now what I have to do, so we have solved it. Now again we have to do add and commit. So once we do add and commit, after we make a commit, your merge is solved, and then we can push it. So what we'll do, we'll just say git and dot git commit -m merged. So see, it gives us a message now, merged. So it says your conflict has merged, and you see that merging has gone now. So your file is updated. Now if I read again the content, so see we have both the changes ready with us. Now we'll push it. Couple of seconds put it. Yep, pushed it on the developer2 branch. Now as a part of next, I will go and raise a merge request again. So when we get back to the browser, come here. So I have pushed into developer 2. So I will just go to the developer 2 branch, and you can see that I have both developer 2 and developer 1 changes here in the developer 2 branch, but in the staging it is still only the developer 1. So see, only the one. So I will create a merge request now. I will say from developer 2 it should go to the staging, and then updated readme with conflict, or I will say updated readme. I will say assign to Maya, do not delete, submit merge request. So now you see the button is enabled now. Why? Because we solved the conflict locally itself before making a merge request. So previously I showed that merge request which disabled green button. Just wanted to show that this is the behavior happens every time when you missed the sequence. So if you follow this sequence tightly, like add, commit, pull, push, then you will never face a problem where this button should get disabled, because whenever you make a pull before the push, you will see the changes which are coming. And if you wanted to go and commit the code and wanted to make a merge request on the branch where the updates have come during the pull time, you will already get notified that okay, we should solve the request, you can say like conflict, or maybe merge the code of that branch locally itself and then push it as a whole. So now it says merge. Now I will say approve merge. Yep, it merged. So you see it says merge and the changes are merged. Now if I go here in the repository and we get to the staging, so see now my both changes are present here. This is the change of developer 2 and this is the change of developer 1. So we have combined both the changes of both of the developers right now. So this is how we solve the conflict for end developers working, and ensuring that whenever they push the code to the repository, it does not create such issue that our merge request gets failed, or maybe we need to close it, or maybe we need to cancel it. So to avoid such kind of situations, we follow the best practice, and always remember the best steps to always push the code is add, commit, pull, and push. And during the pull, always ensure the changes which are coming from the repository. If it's on the branch where you are going to raise your request, ensure that you solve it locally with the steps which I have already explained in the video. So that is all about from this session about the merge request and the code merge. Hope everything I have explained and shown you practically might be well explained. If still there is any open questions regarding this concept, or you want more in detail about this, uh, drop a comment on the video. I will look at it and will try to cover and answer those questions. Okay, and that is all. I think we will meet in the next session again and would bring some interesting, more practical implementations. Hope everyone is doing good, must be enjoying their learnings. Today we will discuss some more features about the GitLab. Most probably these features are not widely used in the projects, or maybe you can say by the GitLab owners, but it's always a good idea to use them, because if they are present in tool, they are there because of some purpose. Let's see what are the purpose behind of those features available in GitLab, and we will try to cover in such a way so each one of you after watching this tutorial can try to implement in their own projects. So guys, hope you all are watching my videos. So if you have any questions, comments, do leave it on the videos comment box and let me know about your questions or maybe doubts at anyone. And I would request you all to please subscribe my channel, like and share as much you can, so it should be spread it along everyone whomsoever is very much interested about these learnings. And for again my Indian friends, दबा दो यार सब्सक्राइब बटन, भाई की चैनल प्रमोट कराओ, एक लाल बटन की बात है, ठीक है, जाओ यार, प्रेस कर दो बस. Okay, so let's get quickly started. Let's move towards our agenda. So today's agenda is we will learn about the GitLab tags based on the releases, wiki, and the snippets. So today we will cover the three more features of GitLab. Without wasting much time, let's start with the first feature. So this is something like GitLab tags based on releases. So as I said, we always ensure that we should keep some evidence. I would say whenever you have a release of your product worldwide, you should always keep a evidence, or you will say a backup, so at any point of time you want to revert back, or maybe you want to look at the code base, you can actually go and revisit that point of time and can see what actually you made the change or was deployed. So like in the life cycle of a product, there are lots of releases happening. Maybe you can say production life. So or maybe you can say a product is launched multiple times. So I would take an example that maybe the product you are developing is launched or deployed 4 times in years, and now I would say that when you had the release of three, and there was some problem, and you need to revert back immediately to release two instead of three, because you need to make immediate change, and that fix cannot be done very quickly. So to make your system available back again, it will be rolling back to the release two, so that your existing system still works on the production environment, and you get the time to fix it, whatever was the problem in the release 3, you fix it, and then you again go for try. So that is where tax ensures that you record each version of your releases and your code base, so you can actually revisit the code at any point of time when it was made a release for the production. Okay, so we will go back and quickly see the practical implementation of it. So this is my repository, Spring Security, where I have created, and every tutorial is going on this same repository itself. So in the last tutorial, we see how much works in GitLab, and we already created some developer 1, 2, and then we made a conflicts and a lot of things. So currently I will go back to the staging. So as you see that I would say that this is the staging code where I have finalized that this code base should be the part of production now. Now to be the part of production, I would have to push it to production branch to ensure that my code base is freeze at production branch, and I will get the code from production branch and go and deploy it. So for that, first I will merge the staging code with my production branch, and to merge it I will quickly go to the branches, and then in the front of staging I would say merge, then I will select the branch as production, I will say compare branches and continue. So I will say product launch, product launch. So I will say this merge will finalize my product launch code base. So now what is saying, I'm merging my dev staging the changes to the production now, and I will ensure that whatever the present in the production should be the part of my deployment. So once I move this one, I will submit the merge request, and I will quickly approve it. Yep. So it says merge successfully. I will go back to the repository now, and once I will go to the production, and you see now all the changes are present, latest from the staging. Right now, I would also like to show you the compare feature, which exactly how it works when you are merging multiple branches. So like, this is the way you will see somewhat when you click on compare. You will say it says source branch and the target branch. So for example, I would just select the source branch as my staging, and I will say production as my target, and when I say compare, so it says there isn't anything to compare. Now this says that there is no change that can be moved to production because they both are in sync. The same way, if I choose the master here and I say compare, so you see it says, okay, there are 40 commits on staging which needs to be catered in master branch. So this is how your compare feature works, and you can know exactly, check, okay, what are, how many commits are not present in some certain branch, and also you can see the changes in which file it was made. So it says, okay, there was one file readme.md where these two developer made the change, and it is not present in the master branch. So this is how your compare feature works. So before merge request, it's always recommended to do a compare between the branches when you're going to exactly make any merge request. Okay, let's quickly back to our topic. So likewise, you see we have the code on our production now. Now it can be used to build and deploy in production server, so it becomes live World Wide Web. So that is how product from starting from development, testing, and goes for production live. Now, once we deploy this code base over the production server, it may happen that on the back, developers are developing still about the product, making some changes to it, or adding more features to it, and then they are still pushing on the staging branch, I would say. So taking that an example, I would go here and just make a small change in the readme.md. I will edit here, and I will add a text, new change for release. Yep, I'll add this comment, and I will commit it. Yep. So see, the change is committed now on the staging. Now you can see that I have on staging now. I can go and quickly merge this with the production branch. So I will quickly select production. I will go here. I will assign it some of the merge request and merge it. So now likewise, you see I have merged, I made the change in the second cycle and I have merged it, and if I go to the production, now you see the one which I released in the first time, now it's not there, it has been updated. So if I want to see, okay, what was there in the part 1 which was released, there is no track back. I need to go to the commit, then I need to see, okay, what all sort of things have been committed before the release, and likewise it would take a lot of time for me to troubleshoot back. To avoid and to easily handle such kind of situations, we uses the feature of GitLab called release in the project overview, or maybe you can say here tags. So I will go back to the releases here. I will just replicate this one. So you see that we have the production branch, and I would say like this code base is now released. I would say, okay, this is change of developer 2, this is change of developer 1, new change for release. Now I say this is going to the production now. Once this has been deployed, I will come to this project over the releases section, and I will click here new releases, or maybe I can select the release date or created date, maybe whatever you want. I will say release date, then I will say new release. It will ask you a couple of things which you need to provide it. So it asks you the name of the tag, so whatever the tag name you want to keep, you want to give. So I will say my product is spring security, so I will say spring security hyphen prod, and then I will mark the snippet as version 1.0. So I will say that this was the version 1.0 release. Then from which branch it should be created. So in my branch, the production releases are going from production, so I will say select the production branch. Now I can give the title So I will say release of Spring Security. Yep. If you have any milestone created, you can select that milestone, or maybe you can manage milestone or whatever. So currently I don't have, so I will not select. Now you can give a couple of notes about your releases. So I will say this is my first production release, and you can add a lot of stuff whatever you want. Like, it should be detailed enough, so any point of time you revisit this release, you can identify, okay, what sort of things have been a part of this release. And then, so if you have any other assets, like you can link any documentation if you have on anywhere in, like, there are lots of tools, you can say, where you manage your documentations. So you can, provide the URL of those documentation. The one of most, I would say, the SharePoint. So SharePoint is an online provided tool by Microsoft, where you can edit all the documents and everything on the web browser itself. So you can provide that SharePoint location, that okay, this is the file. So you can provide the link here and its title. So you also attach the documents which are out of the GitLab, you can say. Once you do that, so I have done with all the stuff. I will say create the release. Okay, so my request would look somewhat like this. After creating a button, it would look somewhat like this. So I will go back just to releases once again. Yep. So if I now come to the releases, it will show me as an header, release of Spring Security, right? So this is my title, and it says assets. So there are 4 assets. Now whatever the code was present in the production branch currently is converted into 4 type format. So first one is the zip format, the other one is the tar.gz, then tar.bz2, and .tar. So these tars are for Linux and Unix, and source code, and for Windows this is a zip code. So now you have the code in the 4 formats, so you can download it from this anytime you want. And next you see the evidence collection. So it says, it gives an evidence that okay, this is the ID which is released. So this is the unique ID, and you see there is a JSON file generated out of it. So if you just quickly go drag it in the browser, so you see it is a JSON file which says release. It says the ID is this, name is release of Spring Security, then it has a project ID, this name is Spring Security created, there is a timestamp, then there is a description, this repo is for Spring Security, then the tag name is this, then when tag was created, any milestone is there or any. So this is in the form of JSON, it's there. So this gives us and it tells about the release note whatever you had. So this is how it orchestrates your release. Now I would say you have the code here in the zip file, but also if you look at it at the below, it says Spring Security prod version 1. What it tells you about, it says that you have a tag. It says tag. So tag means now I will go here repository and you go this tags. So when you created a release, it created a tag for you, and now tag says this was the version ID commit, last commit, that was merging of staging into the production, and it has created a tag. Now if I go into the tag, so what it exactly stating is that it has created a separate you would say a branch, I would say, but we do not say it branch because it's a tag, it's not a branch, because branch is something which can be worked upon or something, but this tag cannot be worked upon. So when I navigate back to the repository here, and if you go back and click here, apart from the branches, you see a new tag is created with the name of Spring Security prod version 1.0, right? So you see another tag is created. Now if I click on this tag, so you have the code here, so you can view it on GitLab as well right away. So you see the GitLab code as well. It also you can navigate here, you can check the current tags, and then you can go to the release Spring Security, which is actually related to your Spring. And if you download the zip file, you have the code here as well. So everywhere you have the code here. Now why we use it? Now let's get back to the same example. Now I say there was a production release. So I would say that code was taken up from the production and was deployed on uh, production server, and we created a tag out of that code. Now if I say in the staging, I will go back, I will edit one file, maybe development is still going for the product, and I will edit this file and I will say new release of product, I will say, and I will add this, commit the change. So I have new release of product on my staging. I will create a merge request. We'll select the branch as production, compare it, and then I will send to me, and then I will not want to collect it. I will say some merge request. Oh, approved and merge. Right. Now if I go back to the repository files, if I go to the production branch, you see the new change which was on staging, now it's on production, and we can take the code from here and deploy it. But now if I want, now if we go to deploy, it will be the part of next release, we would say next version release. Now at any point of time, if I want to go back and check, okay, what earlier we released, so what we need to do, we do not need to go to any commit or something, we can just quickly go here, we can go to the release section and we can check here. So we can download the code here, we can check, okay, this was released on this from the JSON, you can identify which date it was released, that you can find the unique ID. And if you want more details about the code itself within the repository, you can go to the repository, then go to the files, and from the drop down you can select the tag, this one. So if you select the tag, you see the code which is moved from staging to production, but still it's not here. So now this ensures that the release which was made from the production branch and you created tag on top of it, now this tag remains entirely same, you can say lifetime same for the version 1. It will never be changed, or until and unless it has been edited by any I would say purposely or something. But you know, this is all features are disabled, so you cannot change it. So you can only edit these files when you are on a branch. So it says when you are on branch, then only you can edit it, else you cannot edit those things. So this secures your releases. At any point of time, if you have any issue with the release, you can recheck it, and if there is a issue with new release and it takes time to fix, you can go back to your own old release by from using these tags. So that is where GitLab tags based on release works, and they play such important role during your production life. Let's go to the another one, that is wiki. So wiki is here. So wiki says lets you write documentation of your project. So at any point of time, you have a project which is very big, and seeing the code, you cannot understand exactly what the project is about. So you can write about the project in the documentation within the GitLab itself. So like here, we will get started quickly. So you see, create your first page, or maybe you can integrate it using some third-party wiki, or maybe so you can integrate as well. But here I don't have any for the integration, so I will create one. So say create your first page. I will name it as release, or I will say spring. I will say as spring security, and then you can select the format of your document, like it could be markdown, rdoc, skydoc, or org, any one you can choose. So I will choose markdown right now. Then you can provide the content out of it. Okay, this is the spring security project for users. So whatever, lot of documentation you can do for anything. Then you can provide your comment, like okay, document document, like okay, and then you can say create page. So you see the page is created now. It would look somewhat like this way, and you can also clone it on your local, and then you can edit it to clone it, it's very easy. You can just click here, it will guide you all the steps. So for this, like for cloning your repository, it requires git bash. The same way it requires a golang. So golang is one of the library which git tells to install to support its wiki, you can say repository cloning and editing the files and all. So once you install the golang, so you have to use this command like gem install golang. So it will install the golang. Once you have it, you have to use the same command git clone and this url. When you use it and you move inside this, so now you will see a repository, and then you have to just start the golang and edit locally. So for that, you will have to just type golang and it will automatically start, and you will have a file to change. And that is how you do it. And then you have to press Ctrl C to stop editing whatever. So you can make changes locally even without coming here on your own system. And you can select any prototype SSH or HTTPS from here, so whatever you want. So that is how you edit the wiki on the local system. Need to just follow these commands. That's it. And that is all was about the wiki. One more thing I would add here is that, sorry, one more thing. Now if you want to add some links, so I would say then maybe cancel it. Sorry. Yep. So see, this is the document. So now it could happen that you want to navigate, maybe the documentation contains some links which are referred to some other repository, or maybe kind of that way. So for that purpose also, you have a lot of things entitled here. So I would say, if we go back here, so see, there are, as I said, there are 4 formats. So every format has its hyperlink creation. So rdoc follows this snippet to create an hyperlink, markdown follows this snippet to create hyperlink, sky follow this snippet to create a hyperlink, and org follow format this. So I have selected a markdown, so I will copy this one. I'll go here and I'll paste it here, and then say save change. So now you see it says link Google, and it's an hyperlink. So if I click it, so see it opens the google.com. So that is, you can how create an hyperlink to any external repository if you want. So same way like it was my markdown, so it works. I will say rdoc format, and then I will quickly go here and collect my rdoc snippet, and now I'll add here, save the changes, and now see again it's same, right? So it opens at google.com. Now you see it's on the GitLab itself, so you can have it like that way. So this is how it works. And always remember, if you have followed the rdoc format, and if you are trying to select any other format and you have pasted it, and if you do, then it would look something disrupting like this way, because it does not understand that format. So always ensure that whatever the format you are choosing, you should select a particular way to hyperlink it. I will paste this standard format in the descriptions, videos description, so you can get it from there. So that was all about the wiki, and let's go to the next topic, that is snippets. We will talk about the snippet now. So as I already explained in an earlier video, snippet is something where you embed the piece of code on your from your code base. So I will go back to repository, and then I will select some code base from my staging. I will get this one. So I will say this is the code which I need to highlight. So I will copy this. We'll go back to snippets. I will say new snippet, and then I will title it readme code. I can give more description about it. Okay, this code is complex. It calculates the uh, mathematics problem. I would say that way, maybe, whatever. So I give this description. I can name that file. So I name that file as readme.md, and I can paste the content here. Now this is the code which is written, and I will make its visibility as private. You can add more files. So at the time you can add 10 files to the same code snippet if you want. Now once I add it, if you click on here, you get another text editor. You can name a file again, any xyz, and You can also add it here, so I will delete it right now. So once you had the title of the code, you have description of it, then you add the file name and the code in it, and then you say create snippet. So once you have that snippet, now you see when I click on snippet again, so I would see, okay, well, there is one which is with the name readme code authored by this one, and if I go and click here, and it says, okay, this is the complex code, it calculates the mathematician problems. So you have the text to present here, and it shows the file and the change which you have highlighted here. And now anyone from the team can come here, comment whatever they want, and can be look into it. So this is how you create the snippet, and even you can clone this snippet by using an SSH or HTTPS. You can clone it on local, and you can edit it from there as well. So I think that is all comes from the snippet area. Um, that was all about the sum of all the three GitLab tags, paste, wiki, and snippets. So I would say now thank you, and maybe we will come with more practical implementations on more of the GitLab features. We'll explain more about it. And if you have any doubts from an existing session or from this session, please do leave your comments on the video. I would collect them together and try to answer them, and maybe possibly provide a solution against those. Thank you all for this tutorial. Please subscribe, please share. Before we begin to our today's session, please like, share, and subscribe the channel so you get all the updates whatever are going to be posted by me, so you are all up to date with the channel updates. Let's quickly move to our agenda today's. So today we will be starting with CI/CD of GitLab. Now this is one of the most interesting part of the GitLab, or you can say Git, because this brings a lot of easiness while your project development, and it has lots of interesting thing to do. So if anyone is very much interested around these things, then they might like it, and those who haven't been in touch with these things after seeing this tutorial, or maybe after understanding this concept, maybe they would like to enjoy and would like to implement those things, right? So quickly let's go back to our GitLab repository. That is my old Spring security project. So partially, if you see on the left hand side, we have covered almost all the uh, features which are present in GitLab, apart from this package registry and container registry. So package registry, as I already conveyed in my earlier video, that this is something where you manage your packages, but nowadays most of the projects try to manage their packages outside in some artifactory, or maybe inside within the project. So preferably very few projects you would see where package registry is maintained. So we will not cover package registry in this tutorial. We will take it at the last of the session when it was required, or maybe in some last series of the GitLab. Then we'll take about the container registry. We would purely cover it once we move to the container implementation. Going ahead in the tutorials, we'll cover this container registry. And in the operations section, as you can see, there are a lot of options still there, like metrics, logs, and as I already said, these are just intended to be a view your progress of your project, like metrics in the graphical form, logs, or is there any error, or you can set an alerts. So these are things are configurable, and you can know it's very easy to do it. So I would not consider them here. Yes, if you talk about the features flag, environments, Kubernetes, and serverless, so these four things I would cover going ahead. Terraform is a technology, so you can refer to Terraform site about its understanding. But most probably for the Terraform, if you want to understand, please do let me know by the comments to understand the Terraform. Then I would plan it to cover in my upcoming videos. Apart from this, everything else we have covered. Issues is related to issue tracker, which I have not implemented anywhere, but I have already covered an issue tracker example in my earlier videos. So issues is also completed. So all the sections rest are completed. Now we are going to cover this CI/CD section. So I will quickly come here, and you can see that now it's asked for building the pipelines. So let's get back. Okay. So firstly, we understand these four parts of it. So what is pipeline? So pipeline is a feature which brings you continuous integration and deployment. So for example, like you develop a piece of code and then you build it manually and then you go and deploy it on some server. Maybe it could be dev or production, whatever, but that is a process. So what happens, for example, you have developed a code, then you pushed it to your repository, then you took the entire code, then you build it on local, then you test it on dev server, and then you going for production deployment. So these process takes a lot of time when it's manual. CI/CD pipelines, or you can say the pipeline, enables these features that are done automatically. So we tell the pipeline, okay, you have to first take the code, then you have to build it, then you have to test it, and then you have to deploy it. So these all things are done in the single pipeline, automated. You just pass the variables, like, okay, where to deploy, what kind of testing has to be done, how build will be created. So these kind of things you can write in some script form, and these script will be taken up with the pipeline, and this pipeline uses these scripts to release. So this process automates, and it takes a very less time to do this job, where if you talk about the manual, it takes a lot of time or consumes it. So that is where the pipeline roles place comes in. Then we have the jobs. So jobs are nothing in the pipeline. A certain piece of task in the pipeline is performed via jobs. So jobs are just a small piece of token, we can say, or maybe we can say a storage which is assigned for your task, which picks a particular task from the pipeline, align it as a job, execute it into some environment, and then return back the output. So that is where jobs run, and they perform these things. Maybe whole execution of the pipelines, each phases is performed by the jobs. Then we have schedules. So schedules are nothing, you can schedule your run. So for example, there can be two ways. For example, I am a developer, I pushed some code to my repository. Now pipeline immediately started and deployed it on my dev server. Again, another developer developed something, pushed, and again pipeline started and deployed on dev server. Now you see, each time a developer is pushing, the pipeline is running, and it could happen that if the project is big, pipeline is taking up minutes or 10 minutes to deploy till dev server, or passing all the phases, it takes 10 minutes. Now every time each developer is pushing, and it takes 10 minutes time, so in parallel pipelines are running. To avoid such type of situations, if the project is small, then it's fine, but if the project is big and it takes time for testing, building, and everything, so you can schedule the pipeline. So what do you say? Okay, as many push developers want, they can do it in a day. You schedule the pipeline for night 12 p.m. or maybe 12 a.m. night. What happens? Pipeline would run at that particular time, gets all the latest code from that particular branch, assign it to jobs each in each phases, and deploy it on dev server. Next day, developers come and can test it on the dev server. So each day, whatever, so many commits, if there are 100 of commits, doesn't matter, the pipeline would be running at the night. But if there are short commits and you have very few deployments specific, then you can avoid these schedules. The fourth is the image. Now this is the important part of the CI/CD implementation, because image is a very much understandable concept, and you need to understand before you get into the pipeline. So what is image? Image is something where all the recipe resides. So we say images, like for example, you had a Linux server, you perform some commands on those, and you do your activity. Now if I say, for example, I would say you want to build any project, what you will do? You will log into that Linux server or maybe Linux machine. You will check out the code from the Git. manually. Then you will build it using some commands. It will provide some output in that particular Linux machine itself, and then from there you can deploy it. Right now, let's see what are the things present on the Linux system as a recipe. So first you should have a OS, that is Linux. Then you should have Git installed on it. Right. Third, your project dependencies. Now Python project needs the Python modules, then Java needs Maven, then libraries, and Node for Angular projects. For Node.js project you need npm packages. So these all things should be present on those if the project belongs to any of the category. Fourth, you need some locations, right? And the fifth, access to your deployment server from that particular machine. Now these five things you require, right? Now I can avoid the deployment point, like access to the deployment, because this can be configured outside as well. We talk about these four things: the one, OS; the second, your project dependencies; and the third, particular whatever the modules you require for the project; and the last is the artifact, that is the location for the output. So image is something where we club all this together. For example, I have to build a Java project. What Java requires? Java requires a Maven, JDK, and OS. Three things would it be required. So what I will do, I will get an OS image, that is, I will get an OS, that is Linux. I will install Maven into it. I will install Java into it. And then after installing it, I will create one file of entire OS and name it as Maven image. Now what Maven image, now what it tells, okay, so this is the image, that is the OS which has Maven installed on it. So whenever you use this image, you will already have those image installed, that is you will already have Maven installed on it, a JDK installed on it. So anytime anyone using those image or the image which is already configured with those recipes, it will automatically be present in it. So that is very good concept, where you pack your OS with some file name image, and you can use it at any point of time you want. So you do not need, you can use that image anywhere, any system, today in your system, tomorrow in some other system, day after tomorrow in some other system. You have the pre-readiness. It's not that, okay, you got some new system, again you will install everything. So that is where it saves a lot of time. All the configuration can be done, saved into one image, and you can use it from any location. Anyone can use it, right? So these are the four basic things which you know about the pipeline. And then let's get about the project lifecycle. Let's understand what is project lifecycle. So project lifecycle, you see, the first is all properties in detail. So first lifecycle is you should gather all the properties in detail, like, okay, what is project, what is its technology, what purpose it will serve, then what will be the source, what will be the intermediate, what will be the target location where it will be deployed, uh, will it be tested, it will be unit tested. So these are things you inquire about it. So that is all properties and details you should have about it. The second is tools check and qualification. Now you have to check, okay, what kind of tools you are going to use, and their qualifications. So as a standard, or as you can say like that, we should always ensure the tools and the we are using should be very qualified enough, and must be licensed enough. So you make a tool check qualification. Then you verify the to access on the tools, like for example, for storing your artifact, you're using some artifactory like JFrog, or maybe you can say S3, or maybe blob storages. So if you are using this kind of storage, you should always check the access to these tools. Then if you are using GitLab, then you have access to your Docker. For example, there are some new era where Docker implementation is coming. So if you need to use Docker or something, then you need verify whether you have access to the Dockers, you have access to your repository. So this kind of access phases is also there. Then we build the project. Now after building, we check for the vulnerabilities and security, like, okay, whether the project build. After building, we have all the checks around it, like okay, vulnerability, security, everything we verify it. Then we do static code analysis. Now static code analysis is something which is performed by some of the tools. So I would say there are few static code analysis tool. GitLab itself has its code analysis tool, and also we have the market reputed one, SonarQube. So these are the static code analysis tool. What they do, they do a code check on the build and find out the vulnerabilities, smells, and inappropriate written code, or maybe if there is a loop cycle going on, like never ending loop going on. So these kind of hacks, bugs, or things are being checked in the code. So that is where static code analysis is performed as a life cycle. Then we have unit testing on the build, which we have builded, and with the test cases, like there must be some tester who has written those test cases. We will integrate them into unit testing, so these test cases are also tested. So we verify, okay, the product for which purpose was built is working fine. Then after finalizing, we store it to some location. So build is stored as to some location. It can be Artifactory, JFrog, or maybe your S3 blob storage, or maybe your local machine. It can be stored anywhere. Once we done this, then we generate the evidence. Now generating the evidence is a very crucial part and very important part, because like you had a production deployment, and maybe there was some issue, and you want to understand, okay, what was the issue. So you can actually identify, okay, when this was deployed, what was deployed. So there should be some evidence around it. And then once you generate the evidence before the deployment, then you can deploy it on environments. Now it can be any environment: dev, test, val, prod. Most probably among these all points we would cover according to the environment. So like generating the evidence is only required for the production, not for dev. So dev has many types deployment. You do not want to generate any evidence, that's fine. For production, it's very mandatory. The same way, this is the project life cycle, and this is what the pipeline should have. So pipeline should actually undergo with these phases, and you can include any more phases you like, but these are the basic phases of the project that should go on, whether it's manual or it's automated. So that was the project life cycle. Now let's get quickly to the implementation. So you see, GitLab understands the pipeline orchestration using this file. So you have to create a file with the name .gitlab-ci.yaml. So this is the file name. When you create this file and start writing a piece of code at the root of the project, GitLab understand, okay, pipeline, we have to implement the pipeline. So everything GitLab understands from this file. Now this file can be located at the custom location also, but most of the projects you will always find that it is always stored on the root of the project, this file. But if you want to store it on custom, you can go to the settings, you can go to the CI/CD, and here you will find general pipeline settings, under which you will see an option, this one, custom CI configuration path. So like say it says the path of the file configuration file defaults to this one. So it looks in the root of the project. But if you want to have somewhere else, you can pass anyone, like okay, my custom file will be in the pipeline slash and then the file name. Wait, from here, like this way. So now particular GitLab will look about this file inside the pipeline folder, right? So you can change the pipeline anywhere you want to keep. You can have the custom location from here, right? Okay, let's get back now. So let's get into the implementation. So usually I have three branches: master, staging, and production. So we will be working on staging, right? And let's see, here still we don't have any pipelines, we don't have jobs, we don't have schedules yet, right? Now we'll work with the pipeline. So let's get here back. So from the project life cycle, we will first pick this point. So that is all properties in detail. We will declare all the properties at the details of the project. So for that, I will come here. So I have already cloned the project on my local system, so I'm using VS Code for it. You can use any editor, IntelliJ, NetBeans, Eclipse, anyone. Okay, I'll create a file and sorry, I will create a file, and as I said, it should be named as GitLab -ci. Cool. Now I have this file ready with me. So as I already said, the first thing is to ensure that you use the image. So first parameter is the image. So I will say you'll have to use image. Now depending on your project type, you can select the image. So for us, the project is Java, that is Spring Boot security. So for me, the Maven is mandatory and the JDK is mandatory. So I will choose Maven colon latest. Now you see, I said, okay, I need an image that has Maven into it, and I need its latest version. You can have version also like 1.2.1. So it says, okay, Maven 1.2.1 version is required. So you can have version specific as well, and you can say Maven latest. So this is belongs to for Java. Now if you have any Angular project, then you can say image node 12. Right, now what it will do, it will get you the image of node with the version 12. Right, so this is how you can define it for your project image. And if you want more details about the image, you can go to the docker.hub.com, and there are a lot of things would be available for you to study. And if you want to understand about the GitLab images, you can go to the gitlab.com and understand the images what they have pre-installed on it. So let's get, so first thing is the stage is the image. Okay, I will be using the Maven latest image. Then as I said, now the first stage is properties and details. So I will say stages, and now I will say the stage name as properties. Right? Cool. So I defined one stage, that is properties. Now it's always there. You have environment variables on your system. Like if you configure, if you install JDK, you set Java underscore home. If you install Python, then you install set the Python home. If you install Maven, then you set M2. If you install any of the software, Git or something, SVN, you always configure them using the environment variables. So environment variable is a very good practice to follow, because you have a central saved properties which can be retrieved at any time point of time and can be changed just at the single source, and it would reflect for entire source code or anywhere. So it's always practice to go with the environment variables. So I will create environment variables. So in the script we will name it as variables, and then we will declare those variables. So now once you start creating your variables, they would be referred as environment variables. Apart from this, in the script also you can do that. And apart from script, you can go to the settings, you can go to the CI/CD. You see here variables. So this is also um, environment variable. So you can expand it. You see here you can add variables. So you can say add, then you can give the key of it, then its value, then you can tell okay what it is, variable or a file. You can environment scope you can tell, and you can take whether it should be protected variable or it should be masked variable. Now protected is that it should be running only on protected branches and tags only, and mask variable is something it will encrypt your value, means something cross or something. If you see, if I say key and then I say some this value quality and I say mask it, so it says okay the variable quality cannot be masked. Okay, now you see I have given this and I say add variable. So see with when it says protected and masked, when it says masked, you see the values coming as asterisk. You can only edit it and then only you can see it, right? So this is how you can add another variable. for the environment. So you can do the environmental variables configuration here from the settings of CI/CD as well, and you can do it from the script as well. So first I will take it. So I will take one from here and one from there. So I will say first I will create a variable where I will want to know branch name. Okay, from which branch the pipeline was triggered. So I will name it as branch underscore name, and then I will say ci underscore commit underscore branch, right? Now if you talk about this ci commit underscore branch, so default GitLab also had its own initialized variables. So this is one of them. So ci commit branch, this is already defined by the GitLab, so you can retrieve it by this. If you want a list of okay how many predefined variables, environmental variables do GitLab has, you can go to the GitLab site, you can just check for the predefined variables, and it will tell you what sort of predefined variables it already has. So branch name, if I say ci underscore commit underscore branch, this is coming from a predefined variables. All right, now second I would take environment env, and I will say it as dollar, and now I will say environment, right? Now this variable does not belong to particular, you can say the predefined variables. So now I will define this here, I will add it, I will add this key, and I will say staging. So staging is my value, and I will mask it. Okay, cannot be masked, let it be staging, and then I will add variable. Right now I have this variable with me, so it's configured with the key this, so I can use this key to access in pipeline, and I've done it. Okay, 2 1, and third I will take the project name, project underscore name. Yes, right. Now this again coming from the predefined variable, so I say okay, allow me know the project name as well here, maybe I would be using it for my project. Okay, so we are pretty much done with three things. We defined an image, what image we are going to use. We defined one stage, that properties will be the stage. We defined and we declared some environmental variables, and now we will have one stage, that is properties. Let's write, and I will name it as detail, sorry, detail, and then I will tell the stage, we'll name it as properties and script, right? I will tell you all about this. Let me type in first. Hey, this is my first pipeline run, right? And then I will print some values as well. Here I will say okay, and commit on branch. Don't worry, I will tell you all about it. Let me first write it. Okay, cool. Now why I took the project name, as we already know that project name is Spring Security, because pipeline is not for single purpose, also it can be for multiple projects. So that is why I took the project name. Okay, let's see what it did so far. So I said my first phase is detail, and it belongs to the stage of properties. As I said that there will be these many stages, but we can have multiple uh, things to do in the same stage. So I said in the stage of property I will get the details, right? Now what I did, I said then we have the script variable, this script key. What is script key says, whatever you write inside this script is running on the bash of Linux. So like I have chose the Linux image here with the MAME installed on it. So I have used this Linux command, that is echo, and which says to print it on the command line. Now whatever you write in this script is executed on the Linux command line bash and performs a certain piece of task. So I have printed 4 of the lines, that is echo, hi, this is my first pipeline run, then commit on branch, environment and project name. Now you see, this is how I have got it from the environmental variables, sorry, from the predefined variables and from the GitLab variables, assigned it to the environment variables. Now to access them, I'm using in this way, dollar and the name of the variable. So this is how you can access them in the entire script, right? So far we did this. Now we need more things to define, like certain more things. So if I control space, you see these many properties are there to be defined in uh, for one of the phase, I would say. So these many, we will not go for each of them. We will take just select some few specific which is regular and always used. Rest you can cover in some documentation. I would provide the links in the description of the tutorial. You can get it from there and you can read about them. So we would cover only specific which are commonly used and very much used in the project, and also which are a part of mandatory standard and best practice. Okay, so let's go with the after script. So what I will explain each of them. So what after script does, once your script runs, after the job can be set globally for the job. In the sense, like you see, it says defines a script that should run after the job can be set globally or per job. So it says once the job is run, so you had a particular job running, once it's over, after that this script will be invoked. So whatever written here will be run once your job is finished. Then we have this allow underscore failure. Now this I will use it. So this says setting this option to true will allow the job to fail while still letting the pipeline end. For example, you have few stages and among them any one of them fails, the entire pipeline will stop. Now if you want, out of 5 phases you want, okay, any one of the phase if fails, do not stop the pipeline, let the pipeline resume. So what you will do, you can set this variable as true. What it will do, if you have 5 phases and any one of the phase fails, still your pipeline runs if it's do not require any input from the previous phase. So that is where this play I will keep it, and I will keep it as false. So I say if there is any failure in my build, any phase, stop the pipeline. Next, now artifact, as I already said, once you have performed all the certain task via script tag, then you had some output. Now this output should be stored at some location, so that is where artifact tag comes in. So once you pass it, you have it. So for in this stage I do not need artifact because I am not producing any output, so I will not use it. We will use it in when we will build the project. So before script is also, it runs before the job. Then cache, you can use cache, so you know your jobs can have can work on cache, so that things performance increases your build time, and that it supports. Coverage, now it says regular expressions you can use here to cover different areas of the code, and that ways. Dependencies means, like I said, especially a list of jobs names from the earlier stages from which artifact should be loaded, like okay, from where the artifact should be loaded, which are the job by default. Previous artifacts are passed, in the sense from the previous pipeline to the next artifacts would be passed. Or if you have any, like you have 3 stages, now artifact was generated in first one, and then in second one it was just only tested, not passed. In the third stage you can tell, okay, you can get it from the first phase. So that is where dependencies tag comes in. Then environment, you can tell about the environment, metadata URL, okay, what environment are you running for, right? Then except cells, okay, when to run the job. So when you do not define this tag except, so job runs for the time. it is a kind of filter. It says, okay, when this condition meets, do not run the pipeline. So except means when this condition is there, do not run the pipeline. So that is where except comes in. Then we can extend, one more jobs to inherit, like inheritance process, the oops concept. So you can extend parent jobs. So for example, you have a child where you have running something, the child requires something from parent, you can inherit the parent job. The image, as I already said, the image, like image maven underscore latest. So you can define the image name in the phases itself, as well as you can define it at the start of the script. So now when I have decided at the start of the script, now every phase will be using the maven latest image. But if you want every phase to use some different image, then you can certainly have it. Now for example, a single pipeline building both UI and Java project. So if I say like, okay, Java project and Angular project. Now Angular needs Node and Java needs Maven. So what I will do, I will, instead of declaring it at the top of the script, I will define them in the each, like image. When it's Java, I will say Maven latest. When it's Angular running, then I will say Node 12, or maybe any Node version. So image tag is also here. Then interruptible, like, okay, like it should be cancelled if made redundant or something, kind like if, for example, if pipeline runs, now it was deploying in the intermediate line and another request came in for that, and now again it's there. So what happens, the one which was running will be cancelled, the newer one will be taken ahead. Then needs, now this is one of the new feature was added to the GitLab pipeline, which tell, okay, what is needed for the stage to run, and once it has those things ready, it will start it automatically. So what has happened, for example, you had 4 stages. Now you were at one stage, at the stage 1. Now 1 will move to 2, but 3 does not require any input from 2. 3 can run independently. So you can tell stage 3 needs just a start point for first. So if I can say as a condition that if stage 1 starts, stage 3 can also start. So this is where you can tell the each phases or stages needs, okay, when should you start. So I could say like stage 2 has finished and set provided the output, then I can say stage 3 can start running, and it needs only a file at that location. So when it meets, okay, file got stored, run the stage or job. So that is needs it. Then we have only says, okay, pipe job should run when it meets this. Only in the sense, I could say like, if I talk about branches, so I'd say there are 3 branches right now: master, staging, and production. And I say only it should run on master. That even though if you make a lot of commits or merge requests on the staging or production branch, the pipeline would not be triggered. It would only trigger for the master. So that where only those plays it. Then parallel, you can you can split the task for the job to run on parallel. So for example, if there are a lot of things to be done by in single stage, then you can split into multiple jobs to increase the performance. Releases, if there is any release is going for production, then you can use the release tag that creates a release for it. So that is can be resource group, like for example, job concurrencies, that like there are a lot of jobs running and you have a concurrency something, then you can limit those. Means you can say like runner will not run certain jobs simultaneously, in the sense they're not run simultaneously, you limit them. So that is where resource group you can do it. Then you say retry, for example, if job fails, then you can tell what should be the retry phase. Like for example, you say if job fails, retry once. If job fails, retry 2. So you can set retry value like 2, 3. So if job fails for the first time, it will retry again. If it fails second time, it will retry for again. So as many time you give it, it try to retries, but ultimately it will make till then. If it not passed, it will ultimately fail. You can set any rules whatever you want for building or any stage. You can provide any rules for the job. Okay, how it should be done, what should be the order of something, like that way. Any secrets, for the environment, like define secrets to be injected as environment variable. So if there is any password while running, like you have a database, production database, and application needs to connect before deployment, so you can inject that secret password at the time of script as an environment variable. Then services, now similar to image, its property but will link specified services to the image container. So I said it's a container concept. I will cover it later in the container concept, not right now. So starting now, you said okay, when job should start, like it should take 1 minute to start from the previous stage, or it should take 1 minute after the commit. So here you can say start in. Now tags is one of the important part. Now tags is something which you define for the runner name. Now what is runner? Now here let's understand what is runner. So runner is a GitLab feature where this is the runner which performs jobs, I would say. So if you expand it, you see runners need to run your jobs. Like you can set as many runners as you need to run your jobs. So jobs are run by these runners. So runner is very much important. So there are two runners, specific runner or shared runner. Now shared runner is provided by the GitLab itself. So you see there are 14 shared runner which GitLab has provided right now, and these are their runners. And you can also have your specific runner. So you need to set up, you need to follow this instructions, and you can set up your specific runner so that it belongs to your personal runner, so you can use it at any time. Because it's a shared, maybe it can happen that maybe in next 1 minute this runner is getting assigned to some other one, and then if all the 14 of them are used by someone, then I would have to wait till the runner gets available. So that is why you can have your dedicated also, or you can use shared one. And as I said, tags, now you see against the runner you have these blue boxes. Now blue boxes says about the tags. Now here you see the tag is docker. Now docker says it's a docker image. Then if you see Linux, it says okay, it's a Linux image. Mongo, MySQL, Postgres. So these are the name of the images. Okay, Mongo. It means when you say tag as Mongo, so whatever the image you will get, it will automatically have a Mongo in it also. So built-in features are written with the tags. Even though you declare it that you want Maven latest image, still in the runner also you can select okay, what kind of a runner do you want. Like here I can say okay, I want a Linux runner, or maybe I need like GitLab Docker runner, Windows runner, any one you can select from here. So this is the tag, and you should name it inside your this one, sorry. So you can name it here tags, and then I would say okay, I need the Docker run, so it will pick this runner for my job, right? So tags is very important, and it should present in each and every stage. Then we have timeout. It's a timeout. Like for example, I set timeout as 5 minutes. I know that my stage should take only 2 minutes for it. Then I will keep it as a buffer of 4 minutes, and then you say after 4 minutes it should time out. Like for example, if there is any problem trying, and GitLab is trying to reach, and the process is deadlocked, it's remain in the state. Now the pipeline will show running, and it will run. It will go until infinite time. So as I know that my stage will, we should get out timeouted within 1 hour or 1 minute or 4 minutes or 5 minutes, I can set the timeout feature. Then I say trigger. Now like for example, uh, there is another repository or something dependent on your deployment, then I can say okay, once this stage is completed, trigger that, trigger some job, another job. So it would some sort of like downstream, upstream, like a river, it flows. So it says okay, when my repository 1 stage is completed, you can trigger the repository 2 stage. So this is where trigger comes in. Then we have variables, as I already said, environmental variables. So we have declared globally also. You can see we have declared here globally. We can do it within the stage as well. And then what is when? When is the condition okay, when to run job. Describes the condition for when to run the job. Okay, when you have to run. So it also has its default values on success. Okay, it should run on success only. So these are the basics, the properties we had in each is phases. So let's start with the implementation now. So as I said, my stage is properties script. Okay, these 4 lines should be done. Then I say it should fail. The stage should fail. If there is any error, then I will say only. Now only means it should run only for staging. That is I had a branch staging, right? Now if anyone make any changes to master or production, it should not run. So it should only run for staging. Then I'll say x tags. As I said, I need it. Now I will go here, I will search for the GitLab runner which I want, and I would like to have this one, GitLab -org docker. So I will say it as GitLab -org docker. Right, I have done my tags. And then as a next, I don't need timeout, so I will set the timeout, and I will say for, sorry, something is wrong. So it says timeout, and then I'll say for minute. Oh, sorry. Yep. Okay, and then the timeout. Then next. Now when you can define, okay, when now you have, see these many videos of like, okay, it should run always, it should run delayed, it can be manual, it can be never, it can be on failure or on success. So right now I would say it should run for always. Okay, I should run always whenever anything is performed on staging, right? So far we used some of the details. Now I'm sure we are pretty much ready with our initial phase. Now we'll quickly push it inside the repository. So I'm using this VS Code plugin for GitLab. So I will say CI CD YAML file commit. Okay, so it says there is no username configured for my repository. I will quickly set my username. So git config config and user.email. Cool. Okay. Some issue. Let me check. Let me check with the git bash. I think something is wrong here. Let me check. Git config user.email then my email gmail.com. Okay, it's there now. Let me check. Yep, working. Now we'll say push. And I will go back to the repository and go to the staging. Yep, my say ICD file is here, and you can see now we have something blue here which says pipeline running, right? Now we'll navigate to the section of pipeline. So you see already my pipeline is here, and it says the branch is staging. We performed a commit, the commit number, and it says CI/CD YAML file. This is my commit triggered by the user. It does the time. Okay, it took 31 seconds to run, and it happened just now. total it took 31. Now you see stages, it says properties, we have stage property and it is passed, in the sense it is passed. Now this is the unique pipeline ID, so every time the pipeline runs it has the ID, and when it says latest, that means that pipeline was the latest one. Now let's get inside the pipeline. So if you see the pipeline, then it says one job for staging in 31 seconds. So there was one job, as I said, every stage is a job, and you see we have one job here. We have the commit number, no related much request found, and I see pipeline, I see this is the pipeline. So you see I have details, properties as my stage, details as my phase. It says you see this option, it says retry. You can click on it to retry. So if I say retry, now you see again it is started. You now see this cancel button. If you want, you can cancel it by clicking on it and it will cancel the pipeline. Now see if I click here, okay, you see now it is cancelled here, detail cancelled. I will rerun again. So I haven't decided, I haven't declared any needs. As I said, needs you can do, so your pipeline can run at any time with the parallel running phases, which also increases your performance. And you see we have this phase, we have one job, that is with the job ID, this one, where the GitLab tag is this is the tag, that is GitLab org docker. So this is my runner, so my runner is running this job. So details, and the name of that is detail, and it took 31 seconds and it did just now, and what it says, okay, it has been passed, right? We haven't tested anything, that's why it's test 0. So this is running. Now if you want to go more detail, you want to see, okay, what all things happen, you have to click on it. So once you click on it here, we'll get more insight. Now you see it would look somewhat like this. It says job number, this triggered 50 seconds ago by a user. Then you see this Linux command bash. Now you see a lot of things is running with GitLab runner. Now you see this is the runner which was chosen for my execution. Then it says using the docker executor getting the image maven latest. Now this is what I said, that I want maven latest image. So it is getting my image from the docker. Once it got it, it has prepared for me an environment where I can run this. Once the environment is done, and from here it started my execution. Now what it has done, so first is it said pre-clone script, fetching changes with git depth set to 50. Now you see initialize empty git repository in builds. Now at this location it cloned my repository as staging. As I said, it should be staging, so it cloned the repository staging on that particular OS, and then it started to execute the script. So as I said, you see here, this was my script, echo hi, this is my first line. Now it has been printed on the bash. The second one, the branch name. Now you see my execution command was commit on branch, and the branch name which was coming from the environment variables of predefined GitLab variables, and you see now commit on the branch, and it has already taken the branch name as staging. Then environment, right? There's something wrong with the environment, I believe. Maybe could not understand it. We'll take a look at it. Environment. Okay, let me check. Environment. Okay, so there is some issue that it could not read it. We'll check it on this one later. Now you see the project name $project underscore name, and it says Spring Security. So our project name is done, and now it cleans up everything and job is succeeded. Now you see this is how your bash looks like. So whatever you do, you will see all the details here, and you see how much time it took 31 seconds. The timeout was for 4 minutes. If it would have completed at that time, the runner should be the job should be terminated. Then you see about the runner details, okay, which runner was taken for it, and its tag, and you can also see about the job. You can see commit, the number, and you see the history also. Okay, the pipeline has First it was run, then again cancelled, then again run, and you are seeing the particular one. So you can go back to this history. Now you see this bash here. Okay, it was stopped. You can come here, see this. So this is how it looks like when you go to the CI/CD pipeline. It's successfully completed. Now if you want to see something fails, how it looks like, for example, I make a change here and I say uh, I'll make something missing. Maybe I can say here, let's say like this way. Okay, let me take FA. Okay, now I will put this file here. I will put the commit itself, and also push. If you refresh, you see automatically my file failed, and it says okay, YAML invalid error. There is an error in the YAML file. So if you click here, go inside. Now it says okay, found errors in the gitlab.cml job detail. Allow failure should be boolean value. You can test also your GitLab in the CI lint. Now what is CI lint? If you go to your repository, go to your staging, and if you open this gitlab.cml file, now you see, now here it says the GitLab CI configuration is invalid, job details below. So it is now itself says okay, the GitLab configuration is not right. So it automatically detects before you go. So if you open this file in the GitLab repository, you always see this one. Not until and until it is checked or it says is valid, your pipeline will always fail until it says checked verified. So I will again replace back, commit it, and push. Yep. If you come here, refresh it, now you see it says this GitLab CI configuration is valid. So this is how the ultimately, eventually this is the way GitLab pipeline works in, and this is automated details, and it gets manual process and automated. It takes a very pretty much of time to get your things deployed in a systematic manner. So that was all about the first stage. I would also like to add on one more stage here so that we can have clear how second stage will look like. So I will add here the second stage. uh, Let me check about this environment variable. Okay, cncd, I'm going back to the variables. Okay, so it's in staging. Mhm. Okay, so it is marked as protected, and I think my branch is not protected. That is where I feel, yep, that is why, you see its restriction, it is marked as protected, and my branch is not protected, and that is why the variable was not available for me. So I will mark my branch as protected, and right here I'll select staging, I'll say maintainer protect. I say protected branch. Okay, now I have my staging as a protected one, and for tag I don't need. Okay, so now my branch is protected. Now if I get back to the branches, now there should be coming, yeah, now I should read this variable. So we will run it once again in our next stage, and you already see that how it look like in the diagram. Now we will have one more stage, and that was tools check qualification, but I will not cover we can have this tool check qualification, no issues. So I'll say the next phase for me is check. You can name it this way, or maybe let me check. So access on the tools is different. I'll say check tools qualification, then stage. So now, as I said, the next stage is my tools qualification. So I will say I'll limit as tools properties, and tools verify. Copy it. Tools verify and script echo all tools are verified and running, right? Echo q for the demo. Okay, and then again we can say allow false, sorry, right? Then only I would say at staging, then tags, or copy the value, and timeout for a minute, and when on when previous stage is succeeded. For example, I have said when. Now you see on the first stage I said when always, and for the next stage I said on success. So now what it says, it will only execute if the previous stage is success, otherwise it will not run, right? So I have it now. We'll commit it, two stages, push it. If I go back here, go to the repository, the staging. So I had the commit here. Now if I go to the pipeline section, so you see my new pipeline is running, and now you see two stages are here. Let's get inside. Okay, so you see now we have two stages. The one, properties, where details are getting fetched. Second one is tools verify. Now this is verifying the tools. So first one is, so see, first one is successfully passed. Now it's running the next one. So these both are running as in different jobs, and using the GitLab runner. So first one is done. Let's see the first one's output. So it took 32 seconds to execute. So it's the same. So you can see we have the output. This is my first pipeline. We have the commit. Okay, commit was performed on staging. And then you see now environment is coming, staging. Now it's coming because it is protected. And the third one is the project name and the security, right? Now let's get back here. Now you see the second stage is also successfully completed. Let's check. Okay, so you see again it took an image from for the next job. It took an image, it copied our repository, and then it started, and it says okay, all tools are verified and running. Thank you for the demo. So see, this is how the two stages are linked to each other one by one. Also you can run parallel, in the same stage you can run parallel task or make a parallel jobs. So like here the check is going, maybe you can have something parallel here, and then once both of them passes, then you can go further. And now once you see these all things were um, automatic, you can also put some manual also. So for example, I'd say if you have a deployment stage, so after testing, I say you have these many stages, you do all the stages automated, and you can stop the pipeline here after generating the evidence with the manual action. Okay, a manual intervention is needed, that once anyone needs to push or press press play button, or you can say production deployment button, and then it can be deployed. We will cover that in the deployment section once we get it. So far you see how we decorated it, and this is the basic steps in setup you need to follow for the CI/CD, right? Okay, so guys, that was all about the two stages. We checked it. In the next tutorial we would be talking about the access to the tools, building the project, and the other few stages. So we will cover in few stages in few tutorials. If you have any questions or doubts regarding any of the stages or any of the videos, you can drop your questions to the comment section of the video. I would try to get them answered in the upcoming next video. Okay, let's meet in another session now. Thank you all. Please subscribe and share. Have a good day. Bye bye.
Before I begin with today's agenda, I would just like to say please like, subscribe, and share as much you can. People who wants to learn can learn this, who wants to understand the concepts behind can prefer probably these videos. So try to share as much as you can so everyone knows about who needs these videos for their learnings can actually learn about the concepts here. Okay, so let's quickly get started with our agenda today. So last tutorial we saw how CI/CD of GitLab works, and we created two stages printing some text. So we didn't build anything, we didn't created anything. What we do, just we created two stages of GitLab CI/CD pipeline, and we printed some text into those two stages. So that was like giving you the initial how CI/CD setup is done in GitLab. In today, I will explain and build the application using CI/CD concept of GitLab on changing the code. Now, what is on changing the code is like for example, their code lies in the repository inside the GitLab, and when I change code, the pipeline triggers and builds the application. So that is where changing the code comes in. Then after the code is built, I'm generating an artifact or a package. Now artifact and the package is something which is generated via jobs. So every pipeline has multiple jobs, and this job generates artifact. Now this artifact can be an input to the next job, or it can be your final output which can be utilized for deployment, or can be the output of your pipeline. So these we call as artifact and packages. So quickly get started. So what we have to do today, the first we will do some application code configuration for CI. Now every application which has to go through the CI process needs to be configured to compatible with the CI setup. So you need some point you need to change, manage few things, so you make it configurable according to your CI section. So the app which I am taking as a sample would be my Java app, that is the same Spring Security app. So I will take that one. The second step what we are going to do is we will create a GitLab CI file where we will include two stages. The first is the versions to check the version, and the second one is the build stage where my actual application build will happen. The third stage what we are going to do is we'll generate and export the artifact, that is application build file. So we'll build the application, and artifact is like in Java we get jar file, war file. In Angular we get some folders, is files is specific. Then you can say like in different Python we get models. If you have machine learning, then you get models.pk file. So every technology, every application has different build outputs. So that is what we call as artifact. So there are two types of artifact to be stored here. So currently internal GitLab itself has a time period where it can store its artifacts. So like it can be 1 day, 1 week, 1 hour. So it's a short time period where GitLab allows you to store these artifacts for a shorter period of time. And if you want your artifact to be maintained very precisely at a very longer pace, then you can use some external artifact trees where you can store these artifacts. So that now some external artifacts can be like JFrog, your AWS S3, Azure Blob Storages, and then Sonatype, Pendo, Mendix, IronSource. So these are some artifactories where you can know export your artifacts out of the jobs and keep it at location so it can be referred at any point of time when you want it. Okay, so that would be our agenda today. So let's quickly start without waiting. So this is my GitLab repository where I was working in the last tutorial. So this is my latest code base. I have the stages is available, and we have it master, production, staging. So production is something where we have production code, then staging is my development code where I do some development stuff, and master is just like keeping a code base as a backup for me. So I will work on my staging branch. So for now, I already cloned it on my local system, so I will quickly start working directly on on the first section, that is configuring the application. So I have this code base already cloned on my repository. Then I will quickly expand this application. So I have pom.xml, then I will go here to resources, the application properties. So these are the two files which probably I will be going to update, because these are the files where exactly I will make them configurable for my CI/CD pipeline. Okay, so I will update. So my Java version would be 1.8. Then I will say few things like source encoding. Then I don't want this to be included here. We can leave it for now as it. We do not require anything here. I just need to include the name of my build. Now what is final name is something what artifact name I want. So like the artifact, the output which would be coming from this job or the pipeline, I want the name of this file to be that way. So I will name it as Spring Security. Okay, so this would be my artifact name. So this is what my artifact name would be generated, and I'll be using Java 1.8. And then in the application property, I would say it will run on port 9000, and it will be accessible from SS. That is, no, it was a Spring Security. Cool. So that would be my this name. Then let me add here CI management. Then I will add here URL. Then I will give my CI management URL, that is my this GitLab URL, and I will remove it till only this much. So this is my repository URL from where this CI section will work. Then I will say it as system, so I will say Linux, and that is where my CI management is done. I think that's fine for basic building. Nothing more would be required right now. And the second, I have the context path, and I have done the server configuration. So that is all I would require for now. So I will immediately push these changes to the GitLab repository. Git dot git commit -m updating code for CI git push. Perfect. So let it get updated on the repository. Okay, fine, it's done. So our first job is done. Let's get to the second version. This is the GitLab file with 2 stages. So let me quickly refresh and check. Perfect. So we have the configuration loaded now. So now we will work on the other section. I'm going to update my repository again. Okay, so I have all the changes available now. So this is my main class where application will start running, so I don't need to update this. I will just quickly go and update my CI file. So this is my CI file where uh, like I will write about the versions and everything. So first stage I will name it at version, and second stage I will name it as build. Cool. Then I have some variables like branch name, environment, and the project name. Then let me name this as properties, then allow failure, then only on staging. Then I have to use, so like you can see I'm using the common GitLab tag, so I can probably define it here as a common runner. So like GitLab OG Docker. It gives me some error. So what is saying? So give me some error. Sorry. Okay, so we can leave it for now. We'll check on this database, no problem. So we have stages, two stages, then we have variables, and we'll create this as version info, and then we will name it as bear. Okay, so we'll go one by one. Let me have version, then in this I will check some Java related versions. So I will say mvn minus minus version, then I will check Java version, Java minus minus version. So here I will check the versions on which the system is going to work and print them, and it's like always. And then the second stage is build stage. So it's like build, then I will name it as build app, and then we'll use some commands to build. Echo build started, start build started. Now to build this Java application I just need a command called mvn clean package minus t. So I am skipping the test cases here because I don't want my application to run any test cases. So I'm skipping the test cases. So it's maven clean package and minus d skip test. Now once you have this, now I want some artifacts to be generated out, so I will use this artifacts, and now it will ask me for path. So on track, like you can say when your artifact has to be expired. So I say that my artifact can be expired after 1 day, 2 days, and then I can say the paths, and then I will say it would be located inside target folder. So I would say that my path for my, so this is artifact. Now when you any job of the pipeline has this tag artifact, so this is something GitLab CI understands that if you have artifact keyword in your any job stage, that means that job has to produce some artifact that has to be stored inside the GitLab. so that it can be consumed by the next job, or maybe can be used by the particular team after the job has completed. So that is why if you want something out of that job, you need to use this key artifact. Then you need to provide the paths, like from where the job has to get the artifact, like from where. So for me, like when we build some Java applications, the output is always generated inside the target folder. So I have said that from inside the target folder, whatever is built, you can get it out of there. And then I will say the expire time, like when it has to be expired. So I say that this artifact can expire after 2 days. So like after 2 days, this will approximately will be expired, and I can no more access this. So you can define the time period as you want. So then you have other features like exclude. Now what exclude do is, like, you can exclude some folders which should not be part of your export artifact command. So when you are exporting an artifact, if you don't want some files to be excluded, then you can use exclude. If you want this expose as, now there is also other word where you can say like let me do it where it has gone, sorry, this one. So we have expose. So like expose is something where, expose the job artifact in the merge request of UI. For example, if you expose this, then if you are doing some merge request over the GitLab, then this particular artifact URL will be exposed into the merge request. So from directly from there you can get the artifact location. You can name your artifact, what name you want for your artifact. So like I will give it like Maya Java job artifact. So this would be the name of my artifact. Then you have the reports section, where these reports will be uploaded as artifacts and often displayed in the GitLab UI. So where you have merged, you can know what reports are something where if you have a test cases, system test cases, or some test cases are written, unit test cases are written for the application, and you run, and then you can generate this report. Use this report feature to showcase the report onto the UI section of GitLab in the merge request section. Then you have untracked file. For example, if there are any untracked files which are not part of the Git but are generated out of your build application, then you can get those file and put it inside the artifact path. And then third section is when artifacts are uploaded, like job status is completed, failed, and when the artifact should be, for example, your build was started but it was completed in between, or maybe it failed but there was some files generated, so you need not to upload those files. Then you can say, okay, that only on success the artifact should be uploaded. So I say on success it should get uploaded. So inside this I will name it as spring-security char. So this is what my artifact name would be, because it contains a lot other files as well. So I will only get the jar file out of it. So probably my CI file is complete, and what it will do, the first stage will check the versions required, the other stage will actually build the application. So I will quickly go and commit this one. So for this I will use the plugin here, and then I will say, okay, so I will say stage it, and then I will provide commit CI file for building app, and then I will say commit, and then I will say push. Cool. Let's quickly get here and refresh the page. Okay, let's wait, yet not promoted. Okay, so our change is there. Might be our pipeline started running because it has to. Okay, perfect. So the pipeline started running. So we had two stages: the version info, build app. So the pipeline already started running. Let's wait for it to complete till then. So let's open this job. So it's using the same image, Maven latest, which I had used in earlier tutorial. So Maven is where this is the Docker image where Maven, like Java and Maven, already installed, and it's the latest version of the Docker image. So our version info stage is completed. So I'll refresh it. Maybe the build app is going on in the next stage. So building of application is started and version info is completed. So if I look at it, so it says Apache Maven version we have 3.8.1, and then we have OpenJDK 16 installed in this image. So might be a reason my application build might failed because of this version issue. I did not check that, but let's see what happens. So yes, I was right. So it says build fail, and why it says because of the compiler issue. So I was right. I used the as I said, in the version we had the OpenJDK installed. During the build process there was some compiler issue because compiler does not support the version 8 because of JDK 16. So we'll quickly update this. We will go back to version 8. For this I think we need to check with the Docker what version is available for us. So I will get here, I will get to the Docker Hub. So Docker image is promoted by Docker Hub. So the Docker Hub is one of the website where you can know actually get the images already prepared by this one, you can say Docker website. They already prepared this Docker concept images. They had already loaded Docker images with different softwares, different versions of required, and also you can prepare your own Docker images. Maybe in the going later forward, I would probably be covering this Docker concept as well, where I would generate the Docker image for my project according to my requirement and everything. Right. So quickly, I will get this Docker image for Maven. I'll search for Maven, and then let me look Linux official image. Okay, so in this I will check for Linux, and then I will use programming languages. Let me see OpenJDK. So we want this OpenJDK. Okay, so which version we have, we can check the tags. Okay, so we want 1.8, so we can probably look for it. Oracle 8, Oracle 8, Oracle Linux. Okay, so we have this JDK 8 image available with us, so we can use this command to pull it. Or maybe we can check with the other one as well. We can get the Maven as well. Just let me get the Maven. Tags. Okay, so let's quickly check JDK 8 options. So we have this Maven. So you can see like this is what we had for Maven JDK 8, and this is what the Maven command is. So I will use it. Copy. Cool. So this is my JDK 8 and OpenJDK 9 image with the Maven loaded. So let's quickly add it to stage Maven image for JDK 8 push. Okay, then we'll go back and let's quickly see if our pipeline started again. So our pipeline again started. Let's wait. So see, this is what till the time it complete, let me explain. So Docker Hub is the owner of these Docker images, and they made it so simple for you to load OS into any container, getting it used for your CI concepts, hosting the application. So this containerized system gives you a lot of possibility in the area where you need it. Like when you want some systems to be containerized, they give so much powerful tools to you that can be used, and the thing is the power they hold for containerized system is the best right now. So Docker Hub is something very interesting area, and I think probably I would cover these concepts in later tutorial when I will covering about the Docker, what is Docker, how it works, what are Docker images, and different section. Okay, so it fails on the version info. Let me check what is the failure here. So it says Java minus minus version, some error with the argument. So it has the Maven. Okay, there was Java version 1.8, but it gave me error on Java minus minus version. There was some issue with this command. I'm not sure. Okay, probably what could be. Okay, so it's like an older version of Java, but probably this works in because I have tested it many times, and this works. Let me check it on my system. Okay, so minus version it says not because of I think OpenJDK. It might be minus v. Let me check. So it says minus v. No. So it's unloading the main version of the file. Okay, probably we can remove this, no problem for now. At least I'll remove it because I need to build the pipeline first. Then Java version. Now see, this happens sometimes because these Docker Hub images are very custom, and they are like open to public. So these are built on very generic use. Like when I want to use it for my application, I will customize my own Docker image. So that understands my things, my custom commands, everything up to my command level. So that is where I will. So once I will start covering the Docker concept, I will probably explain you about these things. So let's get started. Okay, so our version info stage is complete. Let's quickly have a look. So I have Apache Maven 3.8 and we have the Java version 1.8 available now in our image. And this is a Linux image and the family of Unix. So our version info is complete. Now let's wait for our build app to complete now. So it's using the GitLab org-docker tag as my runner. I'll quickly refresh again. Bring the Docker plus machine executor. Okay, it takes time for pulling the image, I believe. Okay, so you can see here. So it is started building. First, let me go to the pipeline and see. You can see like my pipeline is completed. So it passed. It took overall 1 minute and 8 seconds to build the pipeline. And when I go inside my pipeline, I have two stages which are successfully completed now. If I go to the build app logs, I want to see the logs like what happened during the build process. So you can visit here anytime and you can check everything. So it says you can check it complete raw if you want, and like it says there was downloading some dependencies for my project from the repository, and then it started the building process. After building process, downloading all the images dependencies of jar, it's saying build success, finished in 23 seconds, and then it says uploading the jar file. So this is what upload artifact part comes in. So now it is finding the jar file under the target spring security.jar. Now it says found one match file in directory. So it says there is one file found with this name and uploaded it. Now if you go inside this job, you will see this section job artifact. Here you can see like keeping, like you want to keep this jar, then you can download it from there. Also you can browse it from there. So if I click on browse, it will browse it to the location where this artifact, you can see like this is the target and inside this folder I will have my jar here. So you see this is my security jar of 20 MB uploaded here, and if you want to download, you can download the artifact from here as well, or if you want, you can go back to that same window and you can click on download button to get it directly downloaded. So it will take a couple of minutes and it gets downloaded, and this will remain for next run. Maybe if you will run the pipeline again, this artifact will be overwritten, and if you do not run the pipeline, then this artifact stays for at least 2 days, as we described in our script. So like it is on 2 days. So 2 days this artifact will remain. After that, it will get deleted automatically from this job. And if you run the job within these 2 days, then this artifact will be overridden with your latest one. That is why people usually do not use GitLab artifact restores. They use external like S3, JFrog, and different artifacts. So we have our jar downloaded. Let's open it and see what we have in it. Downloads. So you can see this is the name of our package, what we named it as Maya Java. So we named it as Maya Java job artifact. So this is the name of the artifact, Maya job Java artifact.zip. So I will unlock this zip file. So I will first copy this, or cut it and move it to shared A2A, or paste it here. Okay, then I will extract. Now I have the jar file inside. Okay, so this is our jar file. So I will try to run this jar file and start the application. So I will say java minus jar spring security. So this is the command to invoke the application. So see, it's starting. So it's asking for access. Okay, so it says the application started on port 9000 as we configured, and this is the URL where we can find the application. So I'll quickly go back to the browser. I'll go to the new tab. We'll type in http://localhost colon, the port was 9000 and the path was this. So I will hit it. Okay, something wrong here. Sorry. Yep, cool. Okay. Okay, so it is stopped in between something. Yeah, perfect. Okay, so now it is started. So you can see the login page here. So see, this was the outcome of my pipeline, and you can see now it is generated here. So this is how the artifact is generated, the jar file, the build file, and now when you mix it with CD concept. This was the complete CI concept, and when you mix it with CD, then you make it combine CI CD, and CD is something where you deploy the code. We will cover that part as well when later coming into the deployment section. So my application started, so I will stop it now for here. Now I will show how this pipeline triggers automatically when there is a code change detected now, and application will start building. So you can see this was the last run, and this is what the file updated was. Now what I will do is I will quickly make a small change here in the application. I will make a upgrade here, like adding something. I can say like description I already have. So okay, let's do one thing. We'll add one at the rate get mapping, and I will write it as public string hello, and I will return hello from app. Probably this will not work because it's all depends on the Spring Security config, and Spring Security might not allow this application to access this URL, even though I will name it as hello. Okay, so I say this is the host point, hello from app, and I need to allow this from Spring Security, but I have not loaded the Spring Security yet, so that's fine. Oh, quickly I just want to show how the pipeline works in. So currently you see the pipeline is not working. We don't have any update on this GitLab yet. Last was on 8 minutes, so now I will push this change inside CI trigger pipe, and then I will commit, and then I will push. So pushed here, I will refresh, so change is pushed, and now if you come here in this page, you'll see automatically the pipeline started running. So now the pipeline started running. Now what will happen again here? The same thing will happen. Version info and build will again start getting generated. So let us wait for it to get it completed. Quickly get a refresh. Let me get refresh. So it's starting the build. Let's get here. So this was all concept about the CI main, like how you build the app on the code commit, like on the code pushed in, and then how you can build your application. And then the next phase is the CD process where code deployment happens. So code deployment I did it manually. Right now I showcase how I did it. Now this deployment also gets automated when you come with the CI/CD concept. I will cover that CD part as well in the upcoming tutorial. Okay, so it says build fail here. It cannot import this at the rate get mapping class probably. Okay, so overall the idea was behind this to show how when you push the code what happened. Now if you see this pipeline has failed, so now no artifact would be generated out of this pipeline. The old artifact will be used here. So if you go here, you see this job has failed. So if you want to get the artifact, you won't get the artifact from this pipeline. As I said, that only artifact should be uploaded when the build is complete. So still if you go here, you will find the old artifact. So this is where GitLab also gives you a power that if your next run fails in between, then you can at least get your older version. So this is very helpful when you combine the CI process with the CD. Like if for example you went for the deployment and over during the build process your deployment failed or something failed, then you can roll back to your older versions. So that is where it makes you easy for to understand. So that is all I think from today's session. We covered how to do application code config related to CI. Whatever technology you are using, you can configure it. Then you can configure the CI file with two stages like versions checking, and then you can have a build according to the build stage, and then you can generate and export the artifact as per your application required path, exclude them or whatever, so you can generate them. Now there are two processes: internal, where that is GitLab, that stores for some prescribed period of time or override according to the runs, and external is something where you store it for centuries if you want it, but that's your choice. Okay guys, so that was all for today. I will cover more concept in the upcoming tutorials about different sections, and CI sections, Docker related stuff I will cover in the later going forward. If you have any questions, doubts, you can probably drop a comment. I will try to reply you back as soon as possible. And if you want to learn something about which you want to get in learn, please do leave a comment on the video that what concept you want to learn or what you want to understand. Do leave a comment. I will try to prepare a video on it and will try to share it and publish with you all. Okay, so before I begin, I hope everyone's family and you are doing good, staying healthy. Best wishes from my side. Please like, subscribe and share my videos to everyone so that they get more idea on these things, and also they interact with me closely if they want to understand more things. Okay, be a member of my YouTube family. Okay, let's see what agenda do we have today. So last time we covered how to build the app and generate the artifact using the Git CI. So any CI engine has a process to build the application and to generate the artifact. Artifact is nothing just an output from the jobs of that CI engine that can be consumed by the next job, or maybe by manually you can use that artifact. So artifact is nothing just a output of each job. So we saw that, and if you want to have a more detailed, you can have a look at my older video where I explain about this. Today I will cover the major part that is called the final stage of the CI/CD, which is called as deployment, because without deployment there is no use of having the CI/CD. We will build the pipeline to deploy the code onto the server. So this is one of the very key aspect of CI CD, because CI we have seen what is CI, and now we see the CD, that is code deployment. Now here I'll be using the AWS EC2 server for Linux server for executing to deploy my artifact onto the target server. You can use any server, be it Azure, GCP, or maybe your local server, or maybe any server you can use. So only the prerequisite is to have a server where you can deploy the code and run and provide the access over the browser, or any kind of environment. So the code deployment is the continuous deployment now, and once I build it, then seamlessly whenever I push my code to the repository, it will automatically be built and deployed to the target server. So in that case, it saves a lot of time, and the application is also available within that few minutes. What I will do, I'll build the app. So build the app was from the previous video, so I already reused that code. So now I don't need to build the app. I already inherited that code from the previous video. So now building of app I will skip, and then the next second is to deploy to server. Now I'll create one more stage, which is deploy, and that will deploy the file into the EC2, and then I will access it from my Chrome web browser. The prerequisite only for this stage is to install the required software onto your server, so that the application should be able to run on that environment. Right? I hope everyone is clear with the agenda. Then let me get into the implementation. So go here. So this is my old repository where I used to do stuff. I will go to my staging branch because this is what I work on. So this is my staging branch. I have my code already there, and a Git CI which is doing the building of app and generating an artifact. Now you see this is the IP address of my EC2 instance, which is serving an Apache 2.04 web page that shows okay, your instance is running. And now, as I showcased in the last tutorial, also my Spring application is served on the port 9000. So if I use the IP address of my EC2 instance and use the port 9000 with this, you can say path, context path, then it will say the site can't be reached because currently the artifact is not deployed yet on the server. So you see this site can't be reached. So once we will build the deploy stage, we'll run the pipeline will deploy the code on EC2, then we will see this URL will be working, and we'll see a login form here. Alright, so let's quickly go to the implementation. So this is my code. See, I have locally cloned the code onto my VS Code, and this is the CI file. This is the CI file, and now I will start the okay, let's build the deploy stage. You can see like previously I created two stages, which was version and build, and then I had the code for it. Now I'll build the deploy stage. So I'll say deploy. Now you see this would be my third stage. So I can just copy this one and paste it so that I can reuse few stuff. Alright, then I will name it as deploy, my stage to deploy, and then I'll add one before script here. Okay, wait, let me clean up first this script sections at all. I'll say allow on failure, then it should run only on for staging. When on success, then I will increase the timer to my 10-minute. Then I don't need any artifact out of this. Alright, so now you see I have basic steps. Now I'll add my scripts. Now I will include here before script because I want some things to be set up before actual commands run to deploy the code. So before script is to install the CLI, that is AWS CLI. I need that to run the AWS commands on that Docker image. And for this, I will also change the Docker image because the one above you see is on Maven and JDK. It does not have Python. And for AWS interaction, I would need Python here. So I'll say Python colon latest. So I will use this image for this stage. And then I will say echo. And then I will say installation started, and then I will install my CLI AWS CLI, and then I will check the version of CLI. Alright, so this is what before script will do. It will install the AWS CLI on my Python side, and then I will check the version, and now I will interact with my EC2 instance in the script tag. Okay, alright, what first step we have to do? So first is to generated artifact. This is the generated artifact from the build app. Now I have to copy this artifact into the S3. Now why S3? Because we cannot copy directly to EC2. If we want, we have to use some SSH kind of client, and I don't want to go in that direction. So what I'll do, I have choose the other way, that is to copy to S3 and then deploying it on EC2 from there. So this is the path I use because it's more the standard and the convenient way to do it. So what I'll do, I'll first issue the first command is to copy to S3. So that is something AWS S3, then copy. CP means copy. Spring security, this is my artifact path file, and then copy it to my bucket called maya-pub. This is my bucket. Sorry, this is my bucket, and then I will name it as spring-security. Okay, now what will happen? This command will copy the artifact generated from the build app to the S3 storage on AWS, and then from there I'll copy to EC2 instance. So for that I have an EC2 command called AWS SSM send commands. Maybe I have a copy send commands, right? And then wait, let me copy it from my notebook. I have it on my notebook. Alright. Okay. I'll paste it here, and then I will refactor it a bit. Alright, home. Right. So you see, the first command copies the artifact from GitLab to S3, and then the second command will issue the command on AWS EC2 to copy the file from S3 to EC2, and then the third command will start the application, right? And then it will be apt/app.log. Right. So now the third command will start the application, and then once that happens, we will see the application login page here. Okay. So our deploy stage is complete. Let's quickly push it to our repository. Deploy to EC2. Complete CI/CD. Okay, gate push, done. Alright, you see the code is push. Let me make a refresh. Here you see the code has been pushed to staging and the pipeline has triggered. Let's quickly go to the pipeline. Okay, the jobs have started, so now we will have to take a patience to get this deployed. Okay, in the meantime, I would just request you all guys to please like, subscribe, and share as much you can, and press that bell icon for the latest video updates. Also, I saw many comments on the YouTube videos. I would like all the watchers to provide their comments into the YouTube video itself so that I can get an idea of what content you want. What are you also having any questions, doubts, or anything? I could probably reply as soon as possible on those things. So try posting your comments, whatever you have in your mind or doubts against the videos, so I can get you more clear picture on those things. And this would also help me to identify what exactly you are looking for, and maybe I could add more videos on top of those so that you have a good vision knowledge of these areas which I am currently, driving in terms of YouTube to explain people. Okay, please ask everyone from your organization, from your family, whomsoever is interested, please share this with them as much you want. I need your support to increase the knowledge, vast knowledge around the people who are more interested in this kind of stuff. So your support is well needed, and as a YouTube family, you would once subscribe the channel, you are becoming the family member of my award. Okay, so let's wait till it's get completed. Maybe we'll see it should be a build app. Okay, so build app is passed, so like the app is also built. So if you go here, you will see the build success. You see the build success and you see the job artifact, and now it's on the deploy stage. So let's get this deploy stage completed. Let's wait till then. And also, like, few people have mentioned on the YouTube comments that they want some repository access so they can also refer the code directly. So that's okay. I'll create the separate public repository and paste the public URL link in this video tutorial where I have completed the full CI/CD. I'll paste the link in the description. You can get it from there and have a look at the code base. All right, let's go to see the deploy state. What is happening there? What is going on? Okay, I say this is passed. You see the stage is passed. What is happening? It installed my CLI. It showed me the version of my CLI, and then it uploaded the artifact to the S3, and then it copied to EC2, and then it started the application. So now the stage is complete. This means the application might have deployed on the server. So I'll just make a refresh of this URL, and let's see what happens. It takes time. Not started. Might be something going wrong. All right, let's see. Maybe it takes time to get deployed. Could be a reason. Right, not started. There might be something wrong. Ah, I see. You see, this is wrong. I just wanted to put dot here and I put the slash. Okay, let me correct it. So that is the reason it does not start. Okay, now it should start. Right, all right. Let me push it. Git add dot. Maybe I'll use the same commit. Git push. All right. Then again it will deploy. Let's go back and let's see our staging. So pipeline again started. Okay, we will have to wait now again. So that is the issue. I just put it the opt app /log, so it was just looking for that folder maybe. That is why, but it should be eventually the log file. So now it should work, and let's wait to get it deployed. So please guys, like, subscribe, and share as much you can, and let me know the content what you are also looking for in terms of GitLab. Maybe I would cover them, or in the base concepts of Git, GitHub, any Git repository you are looking reference for. So let's see, it takes time. Okay, so okay, we are on the build app, so it's building the app. Did you see the concept? Like I just changed one thing and then I just pushed it, and you see everything is happening automatically. So this is how helps the developers of the system. They need not to worry about building. They need not to worry about the libraries. They need not to worry about dependence. They need not to worry about deployments. They just do the code, push it, and it automatically deployed. So this is very helpful, a very time-saving concept. And I have already covered the two things, two major parts, and the third major part is completed in this tutorial. So now you have a basic and high level idea how to set up the CI/CD full process. And now you can add on more things, like as a best practice, people say to introduce the validation and testing stage as well in the CI/CD, because for example, like you see, I deployed the code, my stage was passed, but when I referenced here, it was not working. So this is how it's always recommended to use the testing and validation post deployment stage, so that you verify whether the post deployment the application was started or not, the application was available or not. So that is why it's always recommended to have a validation stage to verify whether uh, the code deployed through the CI/CD process is fine, is running or not. So as a best standards, you can add many things, like keeping trace of logs, keeping many things. So you see, it's again says passed, and now you see it might have been deployed. Let me make a refresh. Alright, so you see guys, kudos. We have a sign-in page on my EC2 instance running on port 9000 with the sign-in page. So I'll just do some stuff and I'll say sign in. It says bright credentials. So you see the application is automatically deployed here within few minutes. And now seamlessly, if any developer pushes any change to the staging branch, it will automatically be built and deployed to the EC2 instance. Now this was the case for Java application. The same thing happens for Python, Angular, React, any project. Only the difference would be the commands which are specific to their technologies. All right. So you see, this works. My stage is complete, and this is how the code deployment works. If you have any questions related to this video, to this tutorial about the deployment part, you can leave the comments on this video. I would try to get back as soon as possible. Have a good day. Thank you. Please like, subscribe and share, and press the bell icon so that you